Yeah. All right, we're live.
All right, everybody. Welcome to the Robotics Society of Southern California. My name is Ben Marquita. I am the current president, and this is the May meeting of the Robotics Society. As you guys know, we meet once a month on the second Saturday. Welcome everybody online and the people that are here in person. Welcome everybody, new faces. That's nice. Always good to see new faces. Anybody that's online, if you guys have a show and tell, let me know so I can add you to the list. Same for you people here. If you guys have a show and tell, let me know and I'll add you to the show and tell list. Okay, so Jim,
Big one.
Tim,
does. Oh, yeah. I'm glad you brought something.
if there's no more questions, comments, Alan, you want to take it away?
Yeah, for sure. Let me go ahead and share my screen now. So it has been a very exciting couple of months on the robotics front. So about 6 or 7 years ago, my robot InMoov Grey was contracted to perform a sizzle reel for an Amazon Prime game show. So a sizzle reel is kind of like a highlight reel used to generate interest, and then hopefully you get funding, and then you go. And it was a super fun trivia game with good-looking actors and fun, tests and contests involving like the AI draws a shape. What does the shape look like? And it was a fun-filled, exhausting weekend. One of the photographers, Eric, the guy you see on the screen right now, saw what the robot was, how it moved, and it just sparked an idea in his head. One of the things that I keep talking about with my work with this robot, and he's standing out there with a fresh coat of paint, is that, and you may have seen this in other examples of robotics, you can make something look totally realistic, but if it doesn't, right, it just gives you the total ick factor, right? And you can call it the uncanny valley. I personally think about it as, can this fool your lizard brain? Your lower brain functions do a very good job of separating us versus them, natural versus unnatural. And if you get lizard brain or the brain stem, then you're good to go. So I did a fair amount of work with the InMoov to make it move naturally. If you think of a pan tilt mechanism for a camera, it pans left to right, up to down. You would see this thing move, and you would never think for a second that it was alive or has intent or agency over its movements, because it's just a pan and tilt. And same thing for the robot. If the robot needs to look somewhere, the most efficient movement is just to move your head over and up and over and down. But you see that, and then your brainstem goes ick, and it becomes a machine or something to be ignored or tortured. But if you look at it the way that a human being looks at something, so it starts with the head, and then the body moves around, and the arms change position a little bit. So it's computationally more expensive. It's not as efficient. But now you're moving like an organic creature, and you're one step closer to tricking your brainstem, and in that split second, making a connection with whoever you are working with. So he saw my work on this on the game show, and he's like, "This is amazing. I need to make a movie around it." All right, let's see what you got. So for the past 6 years, he has been working on movie scripts, full-length feature, and over the past year, he discovered that oftentimes the way to get a full-length feature movie funded is to do a movie short. So think District 9. If you're familiar with it, amazing movie. It started with a short to garner interest, and like, we're going to make a movie out of this. So he restructured it into a short story. He set up a film independent page. It's not for profit, just to cover the cost of the movie. And we seem to have a lot of momentum. This is actually going to work. You guys don't want to listen to K-Rock right now? Just a moment. Wrong screen. All right.
So this is your little sizzle reel or something?
Sure, yeah.
Oh, cool.
Oh, this is so that was 7
Sure.
years ago?
Yeah, it was like 7 years ago we did the sizzle reel. Let me go ahead and share this a different way so there's a chance that our people online will be able to see it. Optimize for video clip, just a moment.
That was K-Rock?
Oh, yeah, sorry, I played
that's-
K-Rock while we're
But that's
getting
who
ready.
did this reel? Was that-
Interpreter with live translate, making images.
I don't remember the name of the production.
Empathy sensor, compassion loop, embracing mechanism. Ow! Hi, my name's Eric. Have you been feeling anxious, lonely, disconnected? We all have. These are strange times. Have you been staring at screens, trying to find an answer only to get more questions? Us too. But we're going to do something about that. With the help of my team, we're making a movie called Hold You So Tight. I have one of our actors right here. We realize there are lots of places that need your support right now, but we ask that if you put your resources behind one robot hugging humanity movie so that humanity feels a little bit better, let it be this one. We sure would appreciate it. On behalf of myself and the entire team from Hold You So Tight, thank you.
So a funny story about this clip is he kind of assumes that whenever he talks to me, and it is not. So a day before this happened, he calls me. He's like, "Hey, I need to film a sizzle reel, a stinger clip for this. Can you bring your robot to film it?" So we filmed it next door in ET. And I'm like, "Well, listen, it's not ready yet. It's not camera ready and it doesn't work." He's like, "All right, just bring it." So the robot that was used in this clip was the one before all of the refresh and the updates, and he wasn't operable. But you know, with some clever editing and some ad hoc dialogue, the whole thing fits together. Just reading from the page, he had this idea for a hugging robot. And there's some things I can talk about and some things that I can't talk about. But so he wrote this short about a robot that provides healing through a hug. And we stopped and go for so many times I kind of wrote him off, because you could only school me up so many times before I'm like, "That's never gonna happen." So it was finally happening, and so I got the script, described what the robot needed to do, and I'm like, "All right, well, let's just do this." And I wasn't really emotionally invested in the film or the concept. It's a job, and it's kind of fun to do things on set. So I programmed in a hugging movement, and I'll kind of walk you through what that looks like with the framework I developed a few years ago. And so we came to set, and I had the robots programmed to hug based on specific movements, right? So the hugging sequence was just based around, you know, the general movements, and I let them know when we arrived on set that I would need about 10 to 20 minutes with the actor to customize and fine tune those movements around the exact situation, the height and weight of the actor, how the actor hugs, all these little things, right? And they're like, "Okay, fine." But I gotta tell you, when the lighting was set up and the camera rolled and the actor was on set and we filmed this, something clicked. And first off, the robot performed perfectly, and I'll fill you in on all the things that kind of went wrong that they didn't know about that led up to it. But the robot performed perfectly, the movements were perfect. And so that was the starting point. But I'm watching this, and I'm watching the actor embrace the robot, and they're in a hug, and the robot has grabbed her back and is gently rocking back and forth to kind of, and And I'm like, not only does this work on film, like I got chills, like just watching this, like, cause everything, like I suddenly got the concept, like this looks perfect. The actors selling it, the film, the lighting, the movement, this is not only actually going to work, and now I have high hopes that this is actually gonna turn into something. But getting back to your approach to movement and tricking your lizard brain for a little bit, actually a hug. Like looking at it, watching it on set, knowing everything I did that went into it, Roberta, which is the name of the robot in the film, and Stephanie, the actor, this is a real embrace. So a little bit further on, I had some more time to fine tune the hug sequence. I found a photographer that had roughly the same proportions. And so I borrowed her, and I'm like, hey, can I work with you to fine tune it? So we went over all the safety, you know, the robot can't possibly hurt you. But if anything feels too tight or in the wrong spot, let me know and we'll back out, you know, just so they're comfortable with it. And when she watched, she's like, okay, I'm gonna hug a robot. And so she went in, you know, she grabs the robot and then goes in for a cuddle. And then almost immediately I noticed a change in her face. It was no longer, at least for a brief moment, just, okay, I'm gonna pretend to hug this piece of plastic, to I'm hugging this robot. And I'm like, huh.
Like click?
Like they're having a moment. Yeah. And I'm like, that's really interesting, because she was not an actor. Like,
Yeah.
But, you know, and for all the things that I programmed, there was another piece of that hug that I never even anticipated. And you can see him outside during the break. He's on a pole, and there's a little bit of play between the pole and the base and the pole and the robot. And so a side effect of that is that as the arms move forward for a hug, the robot leans forward a little bit.
Oh, because of the weight shift.
Yeah. So we got that for free. And
It's called for a little bit of free animation there, so.
yeah, free animation. There you go. And towards the end, actually, the producer's wife wanted to get a photo op, and then there was another actor who doesn't actually hug the robot, but they wanted to get some shots and lean in. And I'm watching, you know, the same thing happen. They're going in like, I'm gonna hug a robot, but as soon as they embrace the robot and the robot hugs them back, there's an actual moment there. And I got a chance to ask them afterwards, because I had 3 data points. And it was the same thing. They're like, well, you know, I didn't think too much of it, but, you know, as soon as I grabbed the robot and the robot grabbed me back and started rocking me, I'm like, there's something there. And so, you know, I'm not saying my robot really hugs the sad out of anyone or it's a healing hug, but your approach to movement and your interaction with the robot can cross that uncanny valley long enough and trick your brainstem. Oh yeah, come over.
This is.
To have a moment. So it gets back to your approach to movement can cross that. And you may have seen more extremes of examples of this. There was an art exhibit of an industrial robot that was sweeping sludge, and something went wrong. And just for something going wrong, like people imposed their understanding of it, and they're like, oh, the robot looks sad, right? And that was an industrial arm, but it was doing something that people do. And so it's very interesting psychologically how these things kind of
Made an emotional connection to it, I guess.
kind of fit together. Yeah, if only for a moment. He's all plastic and wires and humming and motors, but
no talking either, right?
no talking. Yeah.
A lot of people connect with robots that talk or something. But I missed it. Was the hug pre-programmed, or was there also a driver like Walter, or live driver? Is it a combination?
Yeah. So the way I saw this working best from early on, and again, the robot is pre-programmed. There's no intent. There's no alive. There's no improvisation in the robot. The robot will always follow a series of motions. And from my previous work, I wrote a back over to Gray here, is I had set up this command program, and it was all done in Python and PyQt with a control surface where I was able to capture movement in the X and Y direction. And then I could program the robot to go through different motions based on that input. And it worked really well before, and so I extended it for here. And earlier on, I'm like, man, I can't script everything at once. So I hired Walter on as a second puppeteer. And I'm like, okay, so Walter, you're going to control the head, and I'm going to control the body. So now we've got some really complex things that we can do.
Oh,
And
so basically, to two, you to control it.
Mhm.
Live control for the.
Live control, yeah. Yeah, and so on the head side, the head had a pan, look up, looking down, and we programmed a variation of that we called the nuzzle. And we can see over here, we have a nuzzle radio button here. And what that was doing, and from watching us like hug the robot a few times to see naturally, after the first day of shooting, we saw how the actor was going in for a cuddle. And so we could see, okay, well, what would be the most natural movement for that? And so we combined, going down with a lean in the head to really lean in. And so we practiced a lot, the day before. On the head side, when the robot activates, it looks right at you. And then when you go in for the cuddle, it switches modes and it kind of leans in. And then I've got the body and the hugging routine. And I'll walk you through in a few minutes about how that worked. But just like I did before, this is all running on Linux and using a technology called X11 forwarding. The tablets or the pendants that I used, I bought a couple of cheap Microsoft Surface tablets. And so, these would go over the heads, and then we could
So that screen was on that screen.
Exactly. Yeah, so we remote on, and then we could just control the movements and change
It's
the
not, you
modes.
can control by looking at it at the same time.
Yeah, so we're standing right, right out of the camera,
Right.
and then we can control it live. So while each individual position in the movement is pre-programmed, we have complete control over how it's approached here. And so, after the hug, the last quadrant was just moving between two positions, a little turn to the left, a little turn to the right, a little lean to the left, lean to the right, a little arm movement. And so I could control how quickly or slowly that worked. And the whole thing, it worked beautifully.
I like to see the scenes. It was like a pretty
It will be
cool
out
watch.
soon.
Yeah, so as soon as they release it, I'll definitely, get a copy out to you. And so we were both running the same program. And one of us would click on enable head, the other one would click on enable body. And
And between the two of you, head and body, it's sort of
We had
coordinate.
complete animatronic framework to bring everything to life.
Like some of the stuff I did with the crypt keeper.
This is in
Exactly, yeah,
wheelhouse.
very much like that.
Was it, did you have to kind of learn how to puppeteer a little bit, or did you already, know a little bit about that from prior?
Well, so I had all of this framework from my last work. This is all available on Alan's Robot Lab GitHub, right? Moving it into ROS Noetic, I just had to change the call out from bin Python to bin Python 3, and then everything still worked. So I had all of this as a starting point. Now, to get the hug animation, first off, it would be a body-only movement. Well, how do you break down a hug? And well, unfortunately, for a couple of reasons, I can't show you on the robot yet, but here, I'll just stand up and kind of show you. Like when you're thinking about how do you hug someone, right? It's like, okay, you just grab them and squeeze, right? That's the way we do it anyway, squeeze the head out of everyone. Well, we've got to break it down into a series of keyframes or key positions. And so there were a couple of positions we needed before the hug started. And then at first I thought we needed 3 keyframes, but it actually ended up being 4 and then 5. So the first part of the animation for the hug was I called it ready for hug, and the arms kind of go out, right? Because then the actor comes in. And then the one that I figured out a little bit later was I can't go straight from here to the hug because it rakes right across their body. So I needed a second movement to bring the arms up a little bit, right? So the actor is kind of in here. And then from here, I could go in and do, this is the one where we had to fine tune, right? So based on the size of the actor,
Right,
is it a body hug? Is she sitting away, right? Like these things ought to be fine tuned. And there was a big safety meeting we had where, because the actor has to be comfortable, because this is just a plastic robot. It's called the hero model. There's only one of them. If this one were to break, there's no movie. And so you kind of have to have this conversation where you have to get where they're coming from, right? And to understand, are they coming from a place of fear? Did they just watch Megan? Right? And so, we have to talk about it in a way that gives them a comfort with the process and the people involved, to allay any fears or misgivings, and to make sure that they're in the right space to be able to do this. Because one strong move and then that's it for the robot, and then filming ends, and we'll have to face Eric. And so that brought us into the hug position, and then in the last minute, the morning of, I'm like, what if we added in a rocking to that as well, so that there was a 6th keyframe, and it was just a small movement. This was keyframe 5, and then keyframe 6 was a little bit to the side and a little bit over, and the arm a little bit down. And then by using the control surface and moving your finger back and forth, you could do it faster or slower. And with the head animation from Walter, like it sold the whole
Oh,
thing.
man, I'd like to have seen that.
Yeah, and you guys will. You guys will. It's all on film. So how did I approach this? So I knew what I wanted to do. So how do I modify the tools to make that happen? Is this control surface was written from -1 to +1 in the X and Y direction. And that's what I had to work with. And for an animation sequence, from 0 to 100, 0 to 200, whatever your max and your min is. So if this is -1 to 1, I'll just add 1, and that gives me 0 to 2 in float, and then multiply it by 200 or whatever, and so now I've got 200 positions to keyframe this. So I divided it into 5 zones. On the left, that would be the initial movement, the power down, and then there was a powered up and ready, and then ready for hug, hug start, hug 1, and then on the very right was hug 2. And so, and I added in a little cursor this time that'll show you where your finger was, so you can go back there. And so you write the code to interpolate between these different keyframes, and then the puppeteer has total control over how you transition.
Sorry, real quick. So if you have the cursor where that star is, and then you accidentally tapped way over the other side, it won't jerk there, right? It'll smoothly.
It would jerk there,
It
yeah.
would, okay.
Yeah, so as a puppeteer, we have to understand how the controller works and its limits. And that was definitely one of the limits that I worked with Walter on, is the code doesn't have any movement smoothing or acceleration or max. And so if you start jerking around in parts of the control surface, the robot will attempt to match those as fast as it can, and some bad things would happen.
Oh, so you have to be careful. You can wreck things just with that.
Yeah. Oh, yeah.
And
Yeah, and at the end of day 1 of filming, one of the neck servos broke.
oh,
And so we had to use a 2-part epoxy to get it to reattach, and it lasted through the second day of filming, but it didn't last for the drive home. So, and
You made it through the shoot.
Oh, made it
we
through
made it through the
shoot.
shoot, yeah.
that's the
Yeah,
key.
and there were a million things that went wrong up until the night before shooting started.
Oh,
Just nightmarish stuff. But,
software. or
software, hardware, things that I missed, things that I did that were dumb. The previous version of this guy ran a full mini ITX PC with Pico ATX power supply. And then I took a couple of 12-volt rails off to a 12-volt to 6-volt buck-down converter to feed the servos. All the servos work off of 6 volts. And then those lines, it's fused off, and there's a power switch, and then it plugs into the power blocks on the back. I wasn't careful with which wires I used for the home run of that power delivery system. And I ended up using brown for hot and yellow for ground. And I forgot that. And so I looked at it, I'm like, oh, yellow must be 12 volts, because that's what it is on a power supply. And so I plug it in and I blow a fuse. This happened 4 or 5 times because I'm not as smart as I look. And finally, I unplugged all of, because each one has power leads. I put them all except for the head, and I plug it back in, and something explodes up in the head. I'm like, well, that's not supposed to happen. That was a polarized capacitor. And I'm like, oh,
Let the smoke out.
maybe unplugging it in backwards. And that one stupid thing blew out 3 servos the night before.
Oh.
So just reversing the polarity blew out.
Yeah, it doesn't sound like that.
Didn't like that at all. Luckily, I have a stack of replacement servos upstairs, so I was able to swap them out and get them installed. And then I had forgotten that I was using an ITX power supply for a computer. And then, because I'm using a Nova now, it's a Raspberry Pi alternative, and it doesn't run off of an ATX power supply. Luckily, I had a 12 volt, 10 amp power brick from a different project. I was like, all these stupid things that I shouldn't have waited till the last minute to do. But in the end, it all worked out. And most importantly, from a production standpoint, it worked perfectly the first time. And if you've ever had the fortune, right? If you've ever had the fortune or misfortune of working in commercial radio, film, all that stuff, it looks like an end-to-end assembly line of hurry up and wait, right? So the first day, we were just fine-tuning stuff for the first 6 hours. We're on the clock, we're on set, but nothing to do. But you do not want to be the person that holds up production when it's your turn to produce, and there's a problem. The last thing you want to do, you have an entire production team, film, sunlight, everything's ready to go. And in this case, we were able to work through all of the issues, and from an Eric, and we brought it, and it worked.
We probably were very happy about that.
Extremely, yeah. I slept most of Sunday.
You don't want the actor or the director to yell at you.
No, definitely don't want
When we were
to.
demonstrating the Group Fever for the first time, and Joe Swivel was in the room, and I was having some problem with the audio. Finally figured it, but boy, he got pissed.
Woof. Yeah, so you always want to be clear. Like in my case, I'm like on day 1, I'm like, just so you know, 20 minutes customized so they can put it on their radar, right? Because if they know about it, they can plan around it.
Oh yeah, for you get it to me or the actor and all that sort of stuff.
Yeah. This is a unique situation. It's the first time ever been done. It probably give you a little bit of slack, you know.
Well, no matter how much they say they do, it's like time is money. And
Okay,
you don't want to be the person holding up. Because from a production standpoint, they're going from scene to scene to scene, so they're working nonstop.
Yep.
With various portions of it, and they film everything out of order. So I'm not going to go through and like, on vacation, here's all the, but I'll show you a few slides that kind of, I guess, prove. So they rented out a recently closed older hotel in the LA area, and then they adapted the script to that scene.
Oh, wow. That's one of the actors?
Yeah, that's, actually I want to call him
Oh,
Ferguson.
okay. There's your robot.
Is it production or the director or are they from here, from Cal State or any?
Not from Cal State,
No. Oh.
but yeah, definitely.
Because you
Southern
filmed
California.
over there, oh, that was.
Oh,
your
yeah,
choice.
because that's where the robot was.
That's
Yeah,
your
yeah,
choice.
yeah.
Oh, I see.
Yeah. A little bit. Yeah, I had a problem with the stringing around one of the fingers. So yeah, here's with the pendants. We're able to get all that to work.
So, yeah, I get no pay.
Yeah. So
Walter's really good, so.
yeah. Yeah, here's both of my old printers running parts for the back 24/7.
It's all PLA?
It's all PLA, yeah.
How'd you smooth everything out?
Lots of sandpaper and filling primer and more sandpaper and Bondo.
Yeah.
And you did that recently.
Yeah, I want to give him a fresh coat
Oh,
of
you
paint.
updated his eyes a little bit.
All right.
That's cool.
And yeah, one of the things before this whole the final maelstrom of work started, I'm like, InMove's kind of fun to work on. You know what? After this is done, I'm going to reprint all the plastics in a different color and then reassemble them. it'll be fun to give them kind of a, no, I'm never touching this robot. Never, ever, ever. And I'm like, if I ever have to do something similar, I'll print out the parts, but we're gonna pay a body shop to do all of the sanding Bondo because I'm not great at it. And you know, during break and afterwards, we'll get the robot. Before filming started, all I could see was everything that I compromised on. The paint job that wasn't perfect, the orange peel on this one part, the 100 little things that I could get perfect if I only had more time, right? And you may or may not be the same way.
Oh,
as
no,
the way
everybody's
my
gone
brain
through
works.
that,
Yeah. And so I go into this thinking, oh my gosh, they're totally gonna notice this corner that, you know, all these 100 things that weren't perfect. But once
But
it
it
was
worked.
on set,
But it worked.
They probably
all of
didn't
that
notice.
fell away and it looks perfect and amazing. And none of those little details matter.
They fall away usually, right?
They fall away and none of the 100 things that I knew I could have made perfect would have made a single bit of difference on the film. Here's an example. The chest plate was all separate pieces. I printed the center part out of resin because I wanted super fine detail for the inset InMoov. And then,
That's not resin printer?
Huh?
Is it resin?
Yep, the centerpiece was resin.
Ooh.
And as you this is after several sessions of sanding and Bondo. The parts fit together perfectly on the computer, but the realities of printing and time and assembly meant that there was a lot of stuff to clean up on. So a lot of this work was done on the chest, similar for the back plates that I did. And the head as well. I wanted to give the head a one-piece look, and for the most part, I succeeded. At one point, we had in scope to do an upgraded eyes with eyelids that could blink, but there just wasn't time to do that. Thank goodness I pulled it because everything else I got finished under the wire.
Do you have a camera in the eye?
There was a camera in each eye. However, they were USB 2 cameras and webcams actually.
Okay.
And webcams are designed and programmed and have firmware to compress a small amount of movement in a full frame.
Yeah.
And then to send out that change of movement fast enough over USB 2 for a webcam to work. In a robot, you have the opposite challenge. The entire head's moving. And if you're getting 15 frames per second by standing in front of the webcam, once you move the entire webcam, that goes down to about 3 frames per second, because now it has to compress the entire frame.
Oh,
So they
wow.
weren't a good fit
It's
for
the
the
whole
eyes.
thing's moving.
And so I just pulled those out for this, but
Okay.
when he had a full computer on the back, he took full advantage of the Connect 2 and the spatial, the 3D camera portion of it,
Mhm.
as well as the eye cameras to do interesting things. Now he's a puppet, so none of that's connected.
When you took on this project, is that what made you decide to upgrade from Melodic to Noetic?
So
And what was the reason for that?
Noetic is the last supported version
For ROS 1?
for ROS 1, correct,
Okay.
yeah. Yeah, so I went ahead and made the leap. Again, there's a bunch of stuff that I did that I probably shouldn't have done. It would have worked just fine on Melodic. I would have to
Okay.
find the previous LTS version of Ubuntu
Mhm.
to run on the Raspberry Pi, the Nova hardware as well. So that might have been a challenge. But I got, everything got worked just fine out of the box. My old framework worked once I changed all the references from Python to Python 3. Because Python 2.7 was retired as of Ubuntu LTS 2004.
Oh, wait,
Super regret.
did you have to upgrade code because you went from
A little bit,
2.7
yeah,
to
because
3?
the Python scripts had to reference Python 3 instead of Python, which was defaulted to Python.
Right,
That was
but
it.
not the code itself, the
No.
code ported fine.
Oh, yeah, yeah, everything else.
Because
is
usually
fine.
2.7 to 3.10 or whatever, or where did you end up on 3.7 or 3 something, 3.9?
3.7 was what I
3.7.
settled on, yeah.
Because sometimes sometimes you have to like change your library or some kind of access. But I'm glad you didn't.
Yeah.
Yeah, so luckily that all worked out. So the 12-volt power brick, I needed to pull out power. So the Nova ran off of a USB-C power adapter. And
So you went in there and modified the board or something?
and so what I did, this is totally MacGyver ghetto, but it worked. So here's the 2.5 amp USB-C power brick that powers the Nova. And then I used 2 hardware electrical connectors that I connected to both prongs of the power plug. And then I ran those over to grab the plus and minus off of the mains for the 12-volt power brick. And you know what, it worked. We used 2 pendants.
Oh, yeah.
Everything worked perfectly except that I didn't use an external Wi-Fi antenna for the Nova. And as well as things work at your house, when you're on set with a room full of production equipment and metal and other stuff, if I were to do this again, I would have used an external higher power antenna to get better connectivity. So we found a happy spot where we could be close enough to be able to work it without having any issues. So that we kind of lucked out on. Here is what the back looks like without the cover on. So I designed and 3D printed some brackets for the Nova and for the power brick. So we've got the 12-volt 10 amp power brick, had more than enough power for the entire system. Here's the 12 to 6 volt buck down converter. So beefy, more than enough for the servos. The Nova is right here. Another thing that I probably shouldn't have done is instead of just using a Raspberry Pi, I went ahead and used this new Nova because it was a lot faster. 8 gigs of RAM, 64 gig eMMC. Fresh to market, there had been some people that had created a version of the OS for it, so I was able to run the right version of Ubuntu 2004. And luckily, everything just worked.
It's a Nova board? It's fairly new, right?
Yeah, indeed, yeah. It is new, and I got super excited because about how fast it was.
Yeah.
And then I noticed there's some even newer boards that are x86 based, like a computer, that are further blurring the line between a Raspberry Pi and a computer. It's just so cool what's out there now.
They're getting smaller, faster, and more.
Yeah.
Are you compiling it through like Arduino IDE or?
The solution actually uses 3 teensies.
Oh.
So they're supercharged Arduinos. There's one in each forearm that controls each arm separately, and then there's one in the head that controls the head, the eyes, and the torso. So I did have to recompile that firmware for ROS Noetic, and that was compiled on board on the Pi, and then exported out, and everything just worked.
And you compiled it through the Nova? Did you have the compiler on the Nova?
Yeah, it's just basically a mini computer at that point.
Yeah, okay.
COVID protocols are in place. Whenever you're doing film shoots, you have to test negative for 4 days prior to the shoot. So we had to do that every day. It's been a while since I had to test myself.
I guess you're okay, right?
Yeah, totally okay. Let me just see if there's any other cool shots before we look at the code here a little bit.
Like, well, that's a good picture. Oh, so that's the hotel that where the set was at.
Correct. Yeah. Most of the principal photography was shot in this one room.
Oh,
And,
man, look at that.
And then there were some outdoor shots on.
It's really hugging her good there.
too. Yep.
Were you able to take these pictures, or were you busy?
These pictures were taken from the set photographer.
Okay, so
It's one running around doing.
there's a guy doing that.
So he gave you a copy, what a shot?
Yeah, they distribute these. These are official shots. They're available to anyone.
And they're public now.
And they're public,
Oh.
yeah, so we can use
Oh,
those.
that looks cool.
There's the
Yeah, so.
Oh, man.
All right, so there's a story behind this. First off, this actor was physically has a larger stature than Charisma. And so we weren't able to complete the hug sequence. That's why the arms are kind of hanging out. Her role was she shows up in tears. And so that's why she's got the mascara makeup on. And she was going through a bunch of stuff. We were just doing a bunch from, happy to sad to angry, just getting a whole bunch of shots. And so, yeah, even here, you can see the head cuddled in, the arms are halfway into the first position. And yeah, it's just amazing. Charisma was the main actor. Let's see if we got a shot of her. So she was in Buffy. If you're a big Buffy fan, you might recognize her. Or the spin-off Angel.
Did everybody like the robot? Less?
Yeah, I mean, he performed perfectly. There was no interruptions to the production schedule. A few people were on the I'm not a fan of robots and artificial intelligence camp, including the I called him Ringmaster Ricardo. He kept everything moving. He's like, I'm just not comfortable. I said, well, you know what? After we get the movements going, you see it, we'll see if you change your mind. So we filmed the scene. He's like, nope. Still not comfortable, not okay.
But it's not AI.
It's a puppet, you're manually puppeteering, it's not AI.
Correct, exactly. But in his, where he was coming from, the whole concept skeeved him out, which is okay. I wanted to get those data points, and some people are just not going to be on board.
Well, I can say AI is the tool, that's all it is.
Exactly, yeah.
It's not going to you do a lot of things faster than you can. It's meant to be an assistant to you, but it's not, doesn't think.
I have a question about the tightness of the hug, right?
Yeah.
You don't have, since you don't, I don't know, do you have any feedback, other than from the person being hugged, like how much pressure for the different sized people, that you want to hug enough that it's something, but not too much and not too little. So
Yeah, exactly, as well as working around the mechanics of the robot. So the robot doesn't have all the same degrees of freedom as we do. There's 3 in the shoulder-ish, and then you've got bicep rotate, right? And so you kind of have to find a position that looks natural, but may not be it, right? So, so we'll get the actor in for a cuddle, right? So, assume a position, they go in, and then we're slowly dragging that slider, and we're watching the movement of each of the arms, right? And as we're moving slowly into position, if we see that it's getting too tight, we'll back it back out, we'll make an adjustment, and then we'll try again, right? Yeah.
Nice.
Not on this robot. I just have positional feedback. So this is all going to be done by eyeballing it, right? And so, we'd back off. I would make changes to the positional numbers for that keyframe, and then we would try again. Yes, the whole thing was safe and slow.
So you can save those. Did you be able to save for different actors into different files?
Not
or
for
just
different actors. Yeah, the file was customized for the only actor that was going to hug. However, if there was in the script to hug multiple people, then we would definitely.
You only
want to
had
save
one,
those.
really,
Right,
but and the rest of them were just
Different
trials.
settings for each one of the people.
Yeah. The framework would support that.
They didn't need that.
So you could have, orange recommend people, you could have a little camera that's like, hello, Danny, and then he knows my hug shape.
Hug
And then he
parameters.
sees, my hug
There you go.
parameters, and then he sees
That
you,
would freak
hello, Alan.
That would really freak somebody
And then he
out.
hugs you, you're
That would freak that
The fact that the
guy.
thing's talking back, like your robot's talking back to them.
Yep. And another thing that came up, because I remember he had mentioned it like a month or 2 ago, is the robot, and you'll see, well, I'm 6 feet tall, so I want a 6 foot tall robot. So when you get everything together with the pedestal, I'm looking him in the eye because the robot is, to scalp, 6 feet tall. And I remember this from the sizzle reel that we shot with him. He's like, can you make it shorter? And I'm like, well, it's just a matter of telling me the height, and then we can have that pedestal aluminum cut to a different size, but it's a one-time thing, and we're happy to do it, right? But just let us know. And then it was dropped. So we get there, and Charisma, she's of shorter stature. She's about 5'4", 5'6". And so me visualizing it, I'm like, okay, well, she just rests her head on the shoulder. But when we got on set, one of the many things that could go wrong when you get everything together for the first time is the director had envisioned it more of on equal footing, right? And so you're like, hey, does anyone have the ability to, cut this down? And I'm okay doing it. I didn't bring
What about standing on a box?
like a chop saw to do this, and I reminded him it's a one-time thing, and like no one on set had the materials to cut this. So we ended up using boxes to bring her up about 4 inches. And so we laid them back, so we walk up. So there's a small continuity issue if you closely examine her height compared to the robot, walking up into the scene versus onto the, no one cares about that movie magic. So they brought her up enough so that she rested her head towards the top of the shoulder, and then the butt kind of nuzzled in.
That's what they use the apple crates for.
Yeah, they looked very much like apple crates, but they were about that tall, and so they could
They
move
were
around
apple crates to begin with.
and stack them, yeah. And so I'm not going to drain the entire framework for you. We've talked a lot about ROS in the past.
Now,
And-
you're running this all in ROS?
Oh yeah.
Last one.
Yeah, and the one thing, like, if, for those of you less familiar with ROS or are not a fan yet, is that once you play by the ROS rules, you get to use all the toys in the ROS toy box, right? So, and without boring you with the details of launch files and nodes and all this stuff, the code that you're seeing right now, and I'm running this in VMware client in Linux, is the exact code that runs on the robot. I'm just going to comment out the pieces of the launch file that launch a program that talks to the teensy, right? Because there's no teensies connected to my computer right now, and those give errors if they're not commented out.
So you commented those calls to start up,
Yeah,
those nodes up.
yeah. And once I hit save on this, I can then bring up the entire robot framework virtually here, and I can do a lot of work without. And we did this a lot while the robot was standing on, on set in the room. Yeah.
Finding the USB port to the exact port every time you boot up. 'Cause what I'm having problems with connecting via ROS serial or a serial node, the port number changes every time I boot up. Is there a way to bind the port with, so every time it boots up, it knows that teensy is that particular teensy, I guess.
So I've got a two-parter to that. So far, knock on wood, in all my experiences, is that once all the peripherals are connected and you reboot, they always come up in the same spot, right?
Okay.
Unless you've done something silly and you lock that port and then you unplug it and plug it back in, it'll give you a higher number, and then I just reboot. So the step one for me in this solution was make sure they're always plugged in the same spot when it boots.
Yeah.
And then they'll always have the same like TTY USB or TTY ACM
Right.
0, 1, and 2. The second thing is to figure out which one's which. And again, in my experience, once you have them plugged in the same way and booted up the same way, they're always in the same spot. And so it's just a matter of doing a little whack-a-mole. You'll set them up in one orientation, and then you'll wiggle a servo, like that was supposed to be in the hand, but it's actually the head. Okay. And I'll flip the bus numbers over here and then try again.
Okay.
And so that's what I've been able to get away with by using the generic dev PTY0. There is an alternative reference for the USB port that does it by ID.
Okay.
And
Do it like a UDEV role or something.
yeah,
right?
it's like dev by ID input and then
Right.
something else.
Okay.
And those should be unique to the device irrespective, but I haven't tried that out yet.
Okay.
I solved that. I had the same problem with the serial coming and going.
Oh,
I
okay.
did custom UDEV rules, so you query the device characteristics and you put like a link in your UDEV rule. You can solve it.
You specify by like the manufacturer ID number or something
Yes,
like that.
exactly. That's
Okay.
exactly. And then you just create a link based on that.
Thank you. That's pretty
Oh, fancy. Nice. All right, so we've got a few minutes left. I don't even. So from here, you can run the bring up script that brings up the framework, and then you can bring up for, your ROS guys RViz with a virtual version of the robot. And from here, I can do my programming and tweaking all on my local copy, and I'll just move the files over once everything's done. The last thing that I did that was kind of new for me on this project is I knew I had to tweak the movements. And anytime you change the code to the command service, you can just exit out and relaunch, but that just seems so pedestrian. So what I did on this project was I used a piece of ROS called the parameter server. There's an entire piece of ROS where you can post variables and stuff to, and you can pull them back out using the ROS framework. And so what I ended up doing was, wait, is that the right one? Oh, nope, that is computer, and I want ROS. Back over here. Was instead of hard coding all of those things into the Python program, I put all of those poses. HYST is Hold You So Tight, that's the name of the movie, as a YAML file, which is then imported into the parameter server. It is a little bit of extra work, but it's not that much. But what that allowed me to do is I could make tweaks to each of the poses here, save off the file, and I wrote a little node that runs with the rest of the ROS framework called hist monitor YAML. And all this little program does is once a second it checks to see if the file's changed. And if the file's changed, it'll upload that updated positional information to the parameter server. So in the background, I can make these tweaks and hit save. And back on the pendant, I added a button called reload poses. So now we can go and fine tune it. And this is still jank. It's not like a full featured position controller thing, but I can make those edits to the YAML, hit save, and then after a second or two, we hit reload poses. And then the program will load the updated positional information without having to relaunch the program. And so this is another one of the tools you get for free. Just use the available stuff. Don't roll your own serial stack for communicating with the teams. You use ROS Arduino serial under Noetic, and then you're going a full 32-bit peer node controller and ROS 2 Foxy. So it's a whole different thing. But use the tools.
Are you using Move It?
Not on this one.
Okay.
I think I have the setup for it on my GitHub, but I haven't done that. Although we have a contest, is it next month? We have a contest next month called Connect the Dots. And my InMoov will be participating. And if I have time, I will try to write a Move It solution for it.
That'd be cool.
And I would like to, and then I'll have two runs. I'll do one run doing the easy way and one way the fun way. And see. So yeah, this is all done. After the contest, he's gonna be mothballed again. He was a completed project 6 months ago. And it was great. It was a rewarding, exhausting experience. Earned a couple of bucks from it. And with any luck, he's going to get a full-length feature movie funded. And
I'll ask you what's next
for that.
If you've succeeded at this, production companies, they're gonna come after you, right?
Yeah. So
Which means
the question
long
became,
nights.
the question became, what happens next? Now, the InMove's a licensed design, and I don't know why Gail isn't responding to my messages and stuff, but we did get permission for this film shoot, but it's not by design, so there's this whole other thing. So Walter and I were joking about, well, what if we built our own? And at first I'm like, no, it's too much work. But then I remember there's this guy out here. This guy's way smarter than me, and he has been working on a hand. And the hand is super expressive. There's 16 servos per hand. Each finger has 3 servos in it.
Now, who did this?
The Robot Studio. He's a guy in the UK.
Okay.
And I'm like, well, that's interesting. It's been in the back of my mind.
So he had that as a kid or something, or?
Not a kid. It's a whole project. And he's also been working on this arm design.
Oh, he publishes everything.
Yeah, he's published everything.
Everything's there and really
And
detailed.
He's also got this arm. Now, I've been following this arm for about a year. And it's fast.
That's not creepy.
Yeah, no, it's got fast motion and it looks cool. And then I happen to notice that every time he posts a video of the arm, he posts a link to the Parasolid parts files on Onshape. Huh, why don't I grab those and import them into Fusion to see if I can work with them?
Sure.
Now, this guy's sponsored by Maxon. And if you've worked with Maxon, you know they do very good hardware, but they're very expensive. Each motor unit, brushless motor, planetary gearbox, optical encoder, and Hall effect encoder, and a control board is about $1,200. And there's 4 of those in this arm. Now, if you buy them, if you buy all 4 of them at once, it goes down to about $900 per motor. I'm like, as cool as this is, I am not made of money, and I do not have 7 grand, let alone 14 grand to blow into arms. So I've been emailing him. We've been talking a lot. I'm actually supporting him on Patreon for a while because I'm using his file. I'm going to be using his files, and so I'm modifying his to use $40 motors instead of $1,200 motors, and those just came in here. They're in ES motors under load. They'll move at 40 RPM, which isn't quite this fast. But they have ones that are faster, but not quite as strong, but they're geared lower that I also like to get a hold of.
How many of those did you buy?
So I got 4. I have enough for one of the arms. And I have enough springs for one of the arms. And so I've got it.
Enough to make one arm.
Yeah, one arm at a time.
Okay.
And we'll see how close, and we'll see if this whole thing works together. So I've been doodling a little bit.
That's gonna be pretty cool. I'd like to see that when you get more into that.
All right, let's do it. So the arm design is really cool. I've brought in the, let this catch up for a minute. You're supposed to be doing faster because set up for video. No? All right, let me stop and restart my share.
Well, it sounds like that movie thing was a pretty cool experience for you there, Alan.
It was a lot of fun, yeah.
Yeah, I can tell you similar stories when I did the Cricket Year for 2013.
Oh, nice.
What do you think?
You guys know who the Crypt Keeper is from Tales of the Crypt?
Yeah.
For 2013, Internet bought all the rights to all 7 seasons of the Crypt Keeper. He wanted to bring back the original Crypt Keeper. I worked on the original Crypt Keeper for a TV show in 1995, 1996. It was on CBS for 1 season called Secrets of the Crypt Keeper Haunted House. It was a game show.
Wow.
So we made a version of the Crypt Keeper that up to that point in time, it took 4 to 7 people to puppeteer it.
That too.
And I reason 1 and 2, they want a light pair of hands from here up.
Yeah.
Otherwise, the whole robot, completely controlled servos and all that sort of thing. Now, at the time that they did this, Raspberry Pis, that wasn't there. So what we used is a MIDI controller that controls motors. It's just a MIDI thing that we use, a MIDI sequencing program to be able to program it originally.
Yeah.
So that was 15 years ago. I hadn't seen it in 15 years. So 2013 or 2012, whatever, I get a call from one of my friends that worked on the project and says, they want us to get the Crypt Keeper going again. Get your ass up here. We're sitting in my thing. We got to get it working again. So we got it working. It took 3 months to get it working, and then they shot it in 3 days on the soundstage in December, and it was on FearNet New Year's Eve.
Wow, that must have been an amazing experience.
Yeah, and I had to revamp some electronics, a lot of the stuff. The thing is, at the time, silicone hadn't been invented yet, so anything that you use for skin was foam latex.
Yeah.
So phone blank tick doesn't last very long because the Crypt Keeper, this version of the Crypt Keeper had, lips, eyebrows and blink, all that stuff had become detached from it.
Yeah.
So what was left is the mouth still worked, the eyes still worked, all the other functions still worked, so we used that. Now, that was the original puppet that we did for that show, and then I had to make a whole new control system that ran off, software from the
Yeah,
company.
Tim, if I could, we're
Yeah.
we're almost
Let's
wrapping
let
up.
him
Yeah,
finish.
no, yeah.
Sorry.
You've got some great stories.
Anyway, we can talk about it later.
So the new design uses 4 of those and like 18 or 20 serial servos. He's got this really cool series elastic shock absorber thing that I'm going to pay a metal fabricator to help me metal parts on. This is one of his claims to fame on it. It just absorbs the shocks for sudden movements for the larger joints to smooth things out. And so using this as a base, I'm like, well, what would that look like if I were to, build a second generation, something that I don't have any licensing issues over. On the movie role, he wants a female presenting robot for it, so I mocked up kind of what that would look like. But make it customizable enough that I could put on different panels or entirely different head for different different uses if we
Well, I'd also make a male version of that, this,
yeah
Oh, so I see,
exactly.
this is, the new film or the future may require a female
Yeah,
boss.
yeah,
That's
so-
why that's partially why you're doing a new design as well as the licensing.
Yeah, so this is the doodle right now is female. I've got I know it looks a little stern and intense right now. These were the eyes made for the InMoov. I haven't customized them yet. Eyes and eyelids.
How did you get the head? Did you do your?
Grab cat.
You did what?
Grab cat.
Yeah, so I'm working on the arms right now, and then as long as these motors work, I'll keep that going in there. But yeah, there's for a couple of different reasons, one of which it would be the full-length production. I think I have a pretty good line on how to do a female version of the robot that I own all the rights to that I could use in movie TV production.
So it could be rented out or whatever.
Yeah, and the last piece that you don't see in here is because he needed to be able to adjust the height. I'm going to build into it from day one the ability to raise and lower by like 12 or 14 or 18 inches under computer control to be able to meet the needs
Lift your
for
motor up and
different
down.
heights. Yeah, yeah.
That'd be cool.
Then you're actually.
So the motors you're gonna get are gonna control the here, here, and here.
Yeah, so going back to the model, there's one,
Mhm.
and then there's 2 and 3 back there, and then the last one of these super strong motors is in the elbow, and then the rest are all serial servos
Right.
that have about 240 degrees of rotation and are controlled using serial commands like 4-hands dynamixels.
That's interesting cable arrangement there.
Yeah, it's super complicated. I might end up simplifying it by the time I get down to the hands, but yeah, that's next on the list is robot arms. So
Is that that's the original
Now,
InMoov hand?
what did you model this in?
So he works in SolidWorks. He exported and shared the file in Onshape as Parasolid, and this has been pulled into Fusion 360. So I'm doing my work in Fusion.
So, okay, someone modeled this for you, basically.
Yeah, this is primarily his design, and then I'm going in and modifying it.
Oh, we're talking about the guy with the arm and the,
Yeah, he designed this from
oh,
scratch.
okay, so that's the one we showed earlier there, okay.
When you're ready to do your metal parts fabrication, give me a call. I have full CNC machines and everything to manufacture
Oh,
parts.
interesting.
So,
Okay.
yeah.
Yeah, I might need to tap you on the shoulder for that. That's
Yeah.
the one thing that I don't, one of many things that I'm not.
Well, you can take your designs and you can.
Yeah, just give me your CAD files and I'll.
Okay, yeah, let's talk. Let's talk, for
Cool.
sure. But yeah, the design's solid. The existing design, he'll let run on a live stream for 4 hours. He'll run it to failure. Like, this is the part that's, the guy's super smart and obviously talented in that. He'll just let it run using kind of random but in scope positions and let it run on a live stream until something fails, and he'll identify the point of failure, and then he'll update the design. Super cool. So the design's mostly been battle tested. I do have to make some changes for the different motor. The motor he's running semi-closed loop. He's got a Hall effect and an encoder on the input shaft, but he doesn't have 1 or 2 encoders on the output shaft. So based on a known initial position, he can calculate out new positions. So I'm trying to work on some things. I want to close the loop and get the output shaft position back as well.
Oh, that'd be cool.
Yeah,
Close
no,
the
so
loop, yeah.
If it's a closed loop, can you grab the, not load cell information, but like resistance and all that?
In the Maxon units, you can. In this one, I just have motor phase as an output,
Okay.
and so I won't have any load sensing on this one. It's 900 versus $40.
Right.
Figured.
I'm working on a gripper right now, and I've incorporated load cells in there so that way I know how much strength to apply. And but I think there's just much more. There should be. I know there's like KUKA robots where it just senses the slightest like human touch and it'll just
they've
stop.
got load cell, they've got current sensing. I've used an FSR. I can show you during the break how I've done it in test. These serial servos have temperature, and the larger servos have current feedback. The smaller ones in the hands right here do not have current feedback, but there's a couple of different options.
What type of servos are you using?
These are E-Tech.
The serial servos?
Serial servos, yeah. All right, so I've gone way too long. Thank you guys for your patience, and I'll keep you posted as this project progresses.
Thank you. Wow, Alan, you really made some major progress there, man.
Yeah.
You know, with your new head design you're doing there, you can reverse that so you can make a skin to put over the top of it, you know?
Jim.
Make a mold.
To continue with the.
Oh, sorry.
Jim, you're up.
Sorry about that.
All right. Let's see. Yeah, so my talk today is definitely we're shifting gears towards the hobby robotics, kind of based more introductory and intermediate level hobby robotics update, and I'm going to cover. Yeah, that's the key. Right. This is so I gave this speech at the OC Maker Faire Meetup, which happens once a month in Costa Mesa. I gave it this month, and I was invited to give a talk, and so it was for a general audience of makers, and they have this once a month now at the Urban Workshop in Costa Mesa, which is right off of Red Hill.
Okay, what's up?
Red Hill in Bristol, and so this club had been to the OC Maker Faire last year, and so we met we kept in touch with the organizers, and then they started doing these meetups at the Urban Workshop just a few months ago. So they're on different topics. I'll just give a little plug for them, but they're on different topics, anything to do with making, 3D printing. They had one on printing materials. They did one on robotics with me, and they'll do other. They did one on setting up your booth and how to be a good booth presenter at Maker Faire and stuff. So if you're interested, check it out. Just type in OC Maker Faire, and you'll see where they have events. You can go, and it's free. And they have, if you want to, you can pay $5 and enter a raffle every month. So, yes, you have a lot of spare time. After you just heard what Alan did, he actually got a paid gig, which is, I've never had one of those. I haven't really tried I'm not sure what, yeah, if I want one, a paid
Hold on a
gig.
minute.
But, so yeah, it's such a sink of time that, you know, but it's something you never regret doing, at least I don't, if you're passionate about it. But, you know, you don't have to devote your whole life to, hobby robotics, like some of us tend to do, or most of it. You can, do something quick and fun and easy, with a lot of these products I'm gonna show. So making something move, that's the key to what got me interested. I'm a software engineer by training, so I have that technical background. I like to write code. But I don't make things move with code, or didn't prior to robotics. So that was a big kind of lure. And it's different than my day job, right? Although there's some overlap with the software, right? And hardware is new to me, so, you get to learn it. So if you're coming from any aspect or you don't know any of it, you're probably used to playing with toys at some point in your life. And so a robot can be a fun toy to play with, or an RC car. So yeah, I say here, also, if you have children, STEM is so big these days, and you know, it's a way you can bond with the younger, you know, people.
Hey, Jim, if you want to turn on your camera, I'll highlight your video.
Oh, to keep the camera on, or you want the camera on?
Yeah, if you turn it on, I'll highlight you.
Right. So, and it's way cheaper than a motorcycle or whatever your other hobby, expensive hobby might be. At least the ones I'm talking about anyway, these. So, oh, by the way, if anybody has any questions, you can just interrupt, because I'm fine with being interactive here. The two main categories, remote control, a lot of this is review for a lot of people, but remote control and autonomous. This club, we're big autonomous fans. We like the robot to do things on its own, based on its sensor input and its prior programming. The remote control, though, is a great way to, and all of us, or most of us, have implemented remote control on our robots, because that's sort of one of the first things you want to be able to do, play around and move it before you get kind of some sort of crazy autonomous, you know, automatic behavior. And so the joystick for flying, obviously, that's what drones are, and flinging its arms around, like you have arms. So autonomous, it's doing things automatic. It can solve a maze, and you can see lots of great videos on that of various clubs, including our sort of another club, Northern California Homebrew Robotics Club, HBRC, and they have a maze contest that they occasionally, once every year, well, once in a while, someone will be running their robot and do the maze challenge. But those are some of those. They have a three phases of maze challenge that you can sign up, and that's in a sort of an official event, as well as Robo Games as well. Although I didn't see maze at Robo Games this year, they didn't seem to have enough people, but they did have a firefighting one, which is kind of similar. Well, although that one you don't, you're kind of given the plan of the little house ahead of time, whereas the maze you're not. You have to find your way to the goal. You'll go down dead ends and you have to figure it out. But that's a cool thing to do. And then collect cans, which is like self-promotion, because I worked on this. This was a contest we had here at this club to collect empty soda cans and put it in a trash can, or at the simplest level, just push it over to a rectangular area on the floor that this is the trash area. So I worked on one, and I did that, the simpler one with the Lego robot. I'll show you that one. And then, of course, Grab You a Beer, which was also done at this club. I never did it, but was the most advanced, one. And that was, build your own fake refrigerator made out of wood and at the reachable distance from your robot and all that, but not a real fridge or anything. But people were able to do that with hobby robotics. Okay. So here's this thing's very sensitive. The different types of robots. It's just kind of a quick outline. You've got the one that I'm most involved with are the wheeled robots. You can start out as a beginner, and for these, 4 wheels, 3 wheels in a caster, which is very popular, and then the 2-wheel balancing, which is what's pictured here. The jointed arm. It's like I've been in robotics since, I've been in this club since 2015, and I've only done really, one of these categories. And so I'd like to move into this one soon. And the simple version of this one, which I bought a kit for. But there's tons of, there's at least these are just some of the types of robots. But I'm representing here, jointed arm. You can be a beginner, intermediate, different degrees of freedom. The quadruped is very popular. The dog bots. I'd say it's a little more intermediate to advanced. You can buy kits that are fairly cheap, that they don't do a great job, but they're a great way to learn how to make 4 legs move. And then insect-like, there's plenty of those, spider-like, and you can, sort of the more higher leg count versions. And then your humanoid, which is what we just heard about. That's advanced, period. Arms and legs, maybe legs. Forward inverse kinematics, reaching out to grab something. So that's kind of the holy grail, I think, is the humanoid. And you can start with, even if there are people that, I went to Robo Games, and they had, this year is in Northern California, there's these humanoid robots that are like, this high, like 1 foot or less, 1 foot and 18 inches, and they play soccer and they're remote control, and they have kits. So you can do that, and they're young people doing this all the time and playing soccer with them, or in this robot soccer. And as soon as it falls, it like rights itself. That's like one of its main functions, or one of its only autonomous functions for these smaller units, that if it falls, it automatically has a way to right itself up. And the person controlling, though, they control the walking and the arms and everything. And though there's also sumo, they use those small humanoid robots to, in a ring, and they try to push the other guy out and knock him down. And it's really fun to watch. I have a whole bunch of videos that I can point you to. I'll repost the link on the website. But I shot 3 days worth, or 3 days, like 8 minutes each of what happened at Robo Games. So you can get a nice idea of what the whole world of hobby robotics is like, all the way from these tiny little things, to these 250-pound battle bots going at it, and in a closed arena with thick glass. Anyway, it's fun stuff. That's like similar to BattleBots, the commercial, the TV show, but this is a separate venue, a separate event in Robo Games. So what is in a typical one? We have definitely a lot of parts. You've got multiple brains, and you've got motors and servos. So the microcontroller is the way most people start. Microcontroller is not quite a computer. It's a small device. It can be like, it's a small board, it could be like this big or a little bigger. And it can handle the lower, I call it the lower brain, or motor side. You can kind of think of it as the lower brain that can control the motors, and it can take in sensors, various simple sensing, like distance of something away, or and then make an LED light up or blink, and things very simple. And that information can be fed, and then it can control a motor through a motor controller. So if you want to make make a lever move back and forth, or a wheel turn, the microcontroller is the thing that actually sends out that signal. That's what you plug into to do that. And then you have software that you write, and it's fairly simple and short code. And you can grab a lot of examples off of the internet, or off of whatever. There's many tutorials and sample code, and the key one to remember is Arduino, which is this club. That's how I got started. It was the first microcontroller and the most popular, called Arduino. And Arduino Uno it's a little board, just a few inches square. And that one takes a 9-volt battery, and there's tons of support and tutorials on how to start out making a red light blink on it. There's a red light, there's a red light right on the board. You can make it blink, that's your first code. And from there, you can go on and you can learn online and on your own. All you need is a laptop computer, and you buy Arduino is a few dollars, like it's very inexpensive board.
Nowadays, you don't
And they're
need a
not
laptop.
available, and they're available.
Nowadays, you don't even need the laptop on your phone, you can get the Arduino.
You can do it on your phone. That I have not tried yet. So there's another, that's even better for people that might not have a laptop or a notebook or any computer, any device that has some sort of port, USB port, like a phone. That's really good to know. So that's your microcontroller, and then for more advanced robotics, you're going to have a CPU, like a computer, and like a Raspberry Pi, or a Windows machine, like that's a Windows single board computer. That handles the higher level sensing, for like vision and higher level decision making, and Python code, and lots more code and memory and all that. And it talks to the microcontroller. So you make a high level decision, a robot go to the kitchen, and then the CPU figures out the details and then tells the microcontroller, oh, hey, start up the motor, the two wheels, and then, okay, stop them, and then, okay, how far away is that, or is there an obstacle in my way, or basically, getting back from the microcontroller a distance from a little, from a sonar. These are sonar transducers here. And so the microcontroller can relay that info. So, and then you have something called a motor controller, which just connects, that is more or less circuitry that drives the motors. It delivers the power at the right level, and the microcontroller sends the pulses to tell the motor controller how much power to deliver to the motor, to the actual motors. So the motors connect only to the motor, they connect to the motor controller, and then it's a different power level. Microcontrollers run off of a lower voltage, and motors run on a higher voltage. So that's why you have this controller to kind of bridge. In fact, it is called an H bridge, but it bridges that power need, and is able to handle the how much power is delivered. And then motors, you have brushed or brushless. Brushless on more expensive ones. The brushed ones are just your typical, very inexpensive motors. They're just it's just an axle, and it turns a rod. That's the motor. You also have servos. Servos, that's for something that you want to control with an angle, like a pan tilt, or like this. This is a servo set. Pan and tilt, so you can, in this case, you have 2 degrees of freedom. A servo can be any joint at all. A single joint is one servo at least. And you can give it an angle, and it knows how to go to that angle. And And there's also, I put sensors in the same block, but sensors are simple sensors like sonar, how far away, hearing, like a speaker, and vision. The hearing and the vision, those go generally to the CPU, as well as things like depth. Well, that's kind of vision. Depth is sort of like vision. Those are enough data. When it's a lot of data like that, it goes to the CPU, that, which is a much more powerful processor. Microcontrollers are very limited processing power, or they can't do that much, but they do it very fast and at a regular clip. So that's why and they don't get interrupted. There's no operating system. They won't get interrupted by an email coming in and having your motors stop. They're very, very little code, a very small amount is repeated over and over again. So that's why I call it the lower brain. Like, you don't have to think about breathing. You don't have to think about, you're keeping your temperature of your body at nominal. It's automatic. So, well, in this case, you do have to program the breathing and when you get hungry. But all right, let's go on here. So these are the different ways to get one. First is what I started out with, and this was one of my earliest robots that I bought, the Wowie Rovio. You can get fully assembled and programmed, great for beginners. That's how I guess you can jumpstart your interest, and some are slightly programmable, but what they do is they at least allow some sort of web interface or some kind of remote control. If you have a remote, essentially it's a pre-built, ready to go, but through some kind of interface, like on your computer or on a remote control, you can make it move and do things. So that's sort of an RC remote control type robot usually, but maybe there's a way to do some programming with some blocks and connect them and get it to do something that you want it to do automatically. But that's sort of the most limited for programming or for customizing. The next level, the middle level, is sort of the sweet spot for beginners all the way through advanced, really, but building from a kit. Advanced people want to do the right one, build it yourself, but building from a kit, I still do it, and I'm still building. I still have several that I have to build, including this one here. This is a McQueen robot, a little roving robot, and I've built ones of those in the past, but those are, and this is a picture of one right here in the middle. Building from a kit is, there's many choices. The prices are lower. 25 is I think it's a little higher. The last one, we gave away a few of these kits at the Maker Faire through a raffle for people, and they, the kids, they're made for ages, 8 and up or whatever. And this is usually simple fittings. They range from putting like 2 parts together to a lot of parts. But the simple ones are very easy to assemble in less than 15 minutes. And you'll learn a lot. You learn about the mechanics, some electronics, blocky programming, or like Scratch, where you're just putting together block, and I'll show you that. And then you can start jumping to written programming if you're interested, but that's usually not required at all. You can start out with putting together these blocks, connecting wires, and then typing some numbers into fields, and that's the software side. The hardware is generally pretty easy, and that's like this kit. And I have the rest of this talk is going to be going through examples of all these types. And then the most advanced is build it yourself. Mechanical, electrical software. And then, you know, that's when you start getting into the robotics is hard, and you may want to throw up your hands sometimes and throw the robot in the river. But no, but then you realize you paid so much, so you don't do that.
Right.
Are you saying that the sunk cost fallacy applies to my favorite hobby?
Oh. Some cost,
In
is
for a
that,
penny, in for a pound.
yeah, is it a fallacy?
The motivation.
I say that lightly, but I mean, you know, usually it's like, you don't even think of, you don't want to harm the robot, but you're mad at yourself more, so it's an internal struggle. Yeah, and then, yeah, you can get involved with a club and enter contests. You can enter contests even from a kit too, if it is somewhat programmable. A lot of kits can do that. And by all, you know, there's also somewhere in between build it yourself and from a kit, there's ones that you can't buy all, you know, in a box like this, but you can, you know, pass this around. But you can go to a web page and it will tell you how to buy all the parts and assemble. And I'll show you one of those too. So, any questions at all before I move into, this is the list of robots now. There's some chats. Anything going on? Okay. So, this is what, the first custom one I built, kind of, or not, I mean, first like partially homemade or partially made from parts that I made with a 3D printer. But this is exactly that example I just mentioned. You don't really buy this in a box. You buy it, I mean, you can, they do have the parts and you can do that, but you can also 3D print it. But this is called Auto DIY, and there's a big community of people behind it. There's different ways of getting the parts, you can buy them. And there's lots of variations and add-ons. And if I go to the, am I sharing the whole screen? No.
That's your PowerPoint.
Oh yeah. Did you pass it all the way? So here, this is what the this is the web page for the Auto DIY, and it's very a very nice introductorial level for starting in robotics, and I do recommend this one. And you code with Auto Blocky, and which is, you know, that's drag and drop and type in like I was talking about. It's very easy, and then, you know, later you can start using actual written code. But to start out with, you use this type of drag and drop, and it's a very easy intro. You also even have a remote control. So I'll let you look at, you know, all these links and all this whole stack. I'll send back up to the mailing list. And if you're not on our mailing list, you know, just email, yeah, please join. But you could always give one of us your email, and I'll forward this. So, and yeah, so that was cool. This one dances. Like so I did this with this robot. One of its most fun things, you can download the code and it dances to a Michael Jackson "Smooth Criminal" for one song, and it does the moonwalk, or it tries to, as much as but this is a bipedal robot, so that is the one with legs I have gotten into. The next one is this Iligu car kit, these are all ones that I've worked on basically, all these, most of them, maybe there's a couple at the end. This is a good beginner car kit. 4 wheels, it's very stable. This one, beginner just / intermediate, I guess, but all 4 wheels are powered. It drives in straight lines fairly easy. Driving a straight line is not easy on a robot, and not on the typical, not on robots in general, because the wheels move at different rate. If it's just what they call a 3-wheeler, 2 wheels and a caster in the back, then it's hard to make the software and the hardware all function so that both wheels move exactly at the same rate. And if one wheel moves slightly more than the other, it's going to turn, and then it starts to wander off the line. So that's like already that's an assignment in school to make a robot go straight. And that difference between open loop and closed loop is what you'll hear. Open loop means it's like, you're not even trying to understand like one wheel is going faster. But closed loop means you're getting feedback from each wheel. The wheel telling you, oh, I just went 5 inches, and the other wheel says I went 5.1 inches. And then you go, oh, well, now I'm going to reduce the power on that wheel, so next time it doesn't go as far, it goes a little less than the other one, and then that's in the software. That's control theory. So that's another thing you learn about the beginning of control theory. But there are systems there you don't have to learn that, like the Lego. You can use a built-in software that will automatically do that. So one of the great things about hobby robotics is you don't have to learn all the way down to the metal. You can pick one of these kits that are, and these lower level, these harder concepts are abstracted or done for you. And then as you get more advanced, you go, oh, I want to know how that works. Then you can upgrade to well, I guess it's in some way it's a mental upgrade to a little bit of a harder robot that lets you tackle that lower level, that lower level programming or whatever it is that was done for you on that easier model. So and there's many options like that when you buy one. And yeah, this one's $55 on Amazon. That's still there. This is one I'd like to get. The illegal. I've seen it work, but I'd love to have a balancing bot. But it's similar. It's sort of an intermediate build, and a great way to get into the 2-wheel balancing. And it's just amazing to watch a robot
I
balance.
have a question. So with something like this, how much weight would it be able to hold on top, do you think?
It may not be able to hold much.
The
Yeah.
taller it was, the more likely it would be to fall.
Yeah, well, if you put weight higher, you're gonna have more of a pendulum effect, right? But these are usually carefully weight balanced for the parameters
Got it.
to make it balanced. So if you add weight, you're gonna have to adjust those parameters. But yeah, you can put weight on them. Obviously, it's got weight on it right now, but yeah, if if you keep it in that center of gravity, and it's not too much, it may not require too much change in the parameters. But as you change the center of gravity, as you're adding weight, it's going to probably require changing. But usually these robots have like a kit like this will have a way for you to adjust those numbers in a sort of easy way.
Is that tray in the front?
This one, I think that's if he falls, so he doesn't like
Okay.
crash.
Okay, yeah.
Yeah, he kind of falls onto that tray.
Okay.
I don't know. That's a good question. It doesn't look like there is one there, but
That's a cool.
So
yeah, this is forward.
Yeah,
Does anybody know? Can't answer your questions because I haven't really.
the trick about those balancing robots is that if you put weight on it, you want to put it as low as you
Low as
can.
possible, yeah, to keep the center of gravity.
Yeah, if you put it up high, like Jim said, you get a pendulum
Mhm.
and it's hard to control. But if you put the weight lower down, it's a lot easier for it, and it just depends on the strength of the motors, how much weight you can put in.
Yeah, this is one area I'm gonna learn about, but here's the different, pictures. Yeah,
Okay,
it's,
so it's
it is on front, so that might be, yeah, I'm not sure.
It's probably designed to like maybe,
It could be a
Oh.
kickstand.
Okay.
What's that? Yeah, what you said.
it's like a little tray that maybe you can put something on it, and something small, and it'll be able to. sit
Maybe
down.
it can handle that.
Yeah.
Yeah, well, the tumbler,
I've ridden the Segway a lot, and the biggest problem with that is parking it. You have to lean it against something and hope it doesn't slide. And I've often wished that there were some kind of a kickstand or something to hold it up. And so I'm wondering if that maybe what that's for, just so
Yeah,
that you
it-
can set
I
it
can't-
down without having
Yeah.
it fall
I
flat.
can't quickly find out, can't quickly see what that is
Yeah.
for, but, yeah,
I'd like to train my cat to drive that thing. Because honestly, you put a small animal in there, and if it's trained, it should be able to lean its way in any direction it wants to go.
right.
Yeah, they say in the description it's a way to park.
Oh, cool.
You press a key, it leans forward, and you park and go up.
Okay, you found it? It is for
So,
parking.
because otherwise you'd have to pick it up off the ground, it's all the way. So, yeah, that's really cool.
Yeah, that's what I figured it was for,
The retracted one.
Fold them.
yeah.
Yeah.
So this one's really good, I'm gonna get that one, for
Nice,
sure, cause if you wanna do your own balancing bot from scratch, it's a bit more effort. I've seen it done, and it's just it's kind of may make you a little bit discouraged or whatever, so I'd rather start with one that's kind of tuned already, get that before trying to do my own balancing bot. That's just what I said there. For the illegal, yeah, generally illegal is that I haven't read about this one specifically, but in general, they just give you the code to use.
The good thing about Illegal is that all the kits, they come with a whole bunch of little tutorials, like.
Yeah, they have-
They give you the entire code for the entire thing, but they give you intermediate steps, like there'll be a
Yeah, I should put
tutorial,
that
how
here.
to use the sonar sensor. There'll be a
Yeah, they're,
tutorial, how to turn the motors.
Cool. And
Yeah,
then
it
the car
comes-
one, it comes with multiple skits, so you can download
Tutorials
all the
and
different ones that you
all-
want.
Yeah.
Because I have that one too.
Oh, yeah? All software code is, that's given to you, and these nice tutorials. So it is, I do like Illegal. It's a Chinese brand, I believe, but $85 for this one, a little more money. But the next one is, this is the BBC microbit I'm pictured here, which is, you can't, and that's like related to this one, or I'm sorry, yeah, this one is McQueen. These are actual McQueens here, which is kind of an older version of this. Those are out of stock and you can't get them, but you can get this one here, which is the one we gave. It's a $30 robot and $30 for the microbit, the new microbit, and it's very similar. What's that?
The microbits are $30.
Yeah, well, if you go to Amazon,
Holy smokes.
otherwise it's hard to get them. And
What
that's
were they
that's
before?
V2. That's
Like
this one.
$5?
Really?
No, they were 10. They were 16 really, and then Micro Center sold them for 10, and that was V1.
Oh, yeah, yeah.
V2 is better. This is like more advanced. It has a speaker on it. It's
Wow.
got like more pins, a speaker, processor, accelerometer, compass. The other one did have accelerometer, but it didn't have a speaker. And this has got more. It's more advanced. It's got radio too. The old one had radio. They don't really call it this doesn't have Wi-Fi per se, but I think that one does. Anyway, yeah, microbit. Well, this is kind of my biggest recommendation because that's why I brought this one up. I'll plug it in and show you that it does. Well, I guess since we're covering this, maybe I should plug it in now. It's got even the software it comes with. It's really a cool demo. See, so it has a speaker, And the old one had this little display as well, but. And and it can send messages. This is similar. This is the same as the old one. This feature, but the new one is better. And then you then you have these buttons here. You can press a button. Now you can press the other button.
Is that the microbit thing?
This is microbit B2.
Oh.
It's a cute little thing, and this you can see. This goes into the robot chassis. That's what is in this one. So this goes into the chassis, and this is the brain of it. And you can even play games like you can rock it, and it knows. You can have a little LED that drops with gravity because it knows the angle you're. Like your phone, you're probably seeing your.
Accelerometer.
It's got an accelerometer. But yeah, this little demo software shows you. Oh, shake. So that's the first thing you can do is shake.
They change the pattern.
Do that when I shake, it does that.
Yeah.
And it plays the music. But when so that's part of the accelerometer. Tilt. So now it's playing that game. Yeah, you can't see because I need another camera here. Oh, I guess this is a camera. This one, as you tilt it, the ball is going down, and see that to win, it's a game. So I'm bringing the ball down into the corner. But it's using an accelerometer to see, and as you tilt, the LED falls, basically. Anyways, this is just a sort of an examination, or a little demo of a lot of the features this has. Oh, now it's got a microphone, so that's new. So you can see that that's like a little level meter. Hello, hello, hello. It's going up in number. So it's got a microphone as well as a speaker. This thing, I mean, it's so much stuff.
How much is that?
This one's, well, if you want to just get it off of Amazon, it's $30, but you can find it cheaper probably. But I didn't have, this one's not easy to get, but this one is here. Now it's just switched to another demo though. It's like finishing up its demo.
Software they produce.
So this one is this one, you can use like TypeScript or JavaScript or Blocky. And, so, let me switch to my web page. So if we're done with auto Blocky. So this one here, Microsoft, you can program it in the microbit with this software on the web called the Make Code by Microsoft, and you can program it like this with, again, these are block coding, and then JavaScript as well. So, and you can even go back and forth between JavaScript and the block code. Obviously this is sort of an advanced program for this thing, because this was, this particular program was for my LA traffic simulation. So it does all sorts of things, like figures out, how far away it is from the car in front of it, and then it stops a few centimeters behind it, and then it beeps its horn and sends a radio signal to the car in front saying, "Get your ass going again." So it's a lot of stuff, and it's also following a black line around as well. So that's why this is kind of beefy amount of code. But to start out with this thing, you can write a few lines of code, and they take you through lots of tutorials. It's very easy. Like here's smiley buttons, make a dice, roll dice. I did this little tutorial. This is the whole program is right there. And so you can shake it. This is a simulated shake, and it comes up with a number. So I could just like take this program and download it and flash it to this board in just a few seconds.
And you're saying if we don't have a board, we could actually log on to this site and then basically run it simulated.
Yeah, so this is really cool that this is a simulator before you even have a board. You can, if you don't want to really shake it, like wreck your wrist, you just click this button. And then, but yeah, it's a full simulator. And what's nice about this as well is it comes with a basic set of features that the board supports, but it also has extensions. And that's what that's how I did my project, Traffic here. I bought, this McQueen robot, and McQueen published a plugin or extension. So McQueen, so whatever, if you buy a robot or some device or like a remote control, it will come with, what is going on? Lord. Okay. If I click here, yeah, you'll see these are the additional features that are added with the robot chassis. So that's what's kind of cool. This whole thing is extendable depending on what you buy. Anyway, that's that one. And yeah, it's you might be able to find cheaper than this, but I didn't have time to look. I bought this one a while ago, and before kind of things got a little bit before the supply chain issues kind of hit. Now, what are we doing? Next. So now we're getting to more advanced robots. I have this one. These are all pictures of mine so far on that black surface. The JetBot AI kit is a really cool. It adds object recognition, facial recognition, vision, AI. This is sort of your entry to advanced, I'd say. And it's expensive too, well, relatively. $255 total for this setup. And the Jetson Nano can be probably found cheaper if you find a used one or some old one. But it is really powerful, and there's wonderful tutorials that go through it. And it serves a web page on its own system. And you just connect to it from your web browser, and you can go through all the tutorials. This one, introduces you to a lot of things, like Jetson Nano running a Linux operating system. So it's a more advanced, but I definitely recommend it. And then next is Donkey Car. I'll just speed up a little bit here. Donkey Car is something I also wanted. These are all things I kind of would like to get involved with. Some of the ones I don't have. I don't have this. This is a whole community involved with racing these and training them. And you're building your own autonomous robot, and you can drive it around, record it, steering angles and all that, and you drive around a track, and then you're teaching it by cloning, this technique of cloning machine learning. So you drive it around, it collects this information through the camera, and then it will be able to re-drive around on its own. And there's people competing with this, and not easy to do, and it takes a little bit of time and effort, but it's a great way to learn this more advanced autonomous sort of driving, entry to autonomous driving. And that's about $250. And there's full instructions on how to buy it and get one. You buy an RC car, a truck, and then you build this stuff on. The orange part is 3D printed, but you don't even need a 3D printer. You can get that part. Then here's an example of one I have that I have not built, and other people have built it. The quadruped that everybody loves, is loving quadrupeds now. This is only $116. It it's not like gonna be like Spot from Boston Dynamics, let's be quite frank. It can barely move forward, or it does backward better, but for some people who have built it. But it is it is a way to get into a quadruped for under $150. And it's this one, there's other models like this. This one, it takes at least 6 hours to build it. So it's, it's like for people that like to build kits. This, and all the instructions are pretty good in here. So I am gonna build that one, I have that one. This is another one I have that I have not really built yet or put together. The Mark Make a Robot Kit, that's about 219. So these are the more advanced one. This is an AI kit. They're all made for children. I mean, all of these, the ones that, this one's comes in a box, as opposed to the other, the donkey cart is kind of, you have to follow directions and buy the parts. So this one is really got some good potential, and it was a lot. It went on sale when I bought it, so you might look for another sale. It supports Scratch too, which is good for the younger. Scratch is the block programming. It's the most popular one. And finally, we get to the, my build, advanced, long-term, many features, but years of extendability software. It does mapping, 3D, 360 laser, touchscreen, radar, sonar, SLAM, computer vision. It talks and it understands you. I even put with the talking robot. I ran out of room, and your cost is equally higher for all that stuff. And so that's like, after a few years in robotics, you may want to do this type of thing. So in summary, getting started is easy. Choose a type, start with whatever level you're comfortable with. I recommend going with one of those programmable kits, that middle Goldilocks, if you're at all beyond just buying a thing that it's already fully built and works with a remote control. The microbit is, look for ones with good directions and examples. The microbit board, along with compatible chassis, is a very good starting point. The one link I showed you there, it looks like this. It's very similar to this McQueen. It's just a different brand. It's like 2 wheels and a caster, and it fits in your hand. And there's always more advanced ones. Micro Center is a good place if you want a brick and mortar store. So that's it for that. I'll take any questions. 12 o'clock, look at that. Thank you.
All right, good.
All right, well, we break exactly at 12, so let's try to come back 12:45, 12:50, so we can continue the meeting. Show and tell, and welcome everybody, welcome back. This is now the show and tell for the Robotics Society of Southern California meeting. And Jim, you are first on the list for show and tell.
All right. So let's see. Okay, let me share my screen here. Back to the web page. So we had a good show at the Maker Faire. I added the last 2 shows we were at. So I mean, I'm gonna find some more whatever pictures. I'm still waiting for people if they have any of the earlier one. But this from last year. But this was the LA Maker Faire on April 1st, most recent one.
That was fun.
yeah, we had, these are the people that we had, myself, Ben, Thomas, Carl, Chris Mayer, he's a new member, and Tim, and yeah, Carl, and so yeah, we gave away these 2 microbit version 2 based robots, and with the raffles and hundreds of our new business cards. So that was a good, very good event. And here's some of the pictures. Yeah, I brought a few robots. I had 3 different demos going.
Yeah, orange, you got your game.
And I had the orange, and I had the track, and I also had the virtual member, Cooper.
How come Cooper didn't come to this meeting?
Oh, yeah, Cooper's a little tired from staying up, working on chatbots, but yeah. Yeah, well, I hope to have Cooper as a regular attendee, right?
That'd be nice.
Yeah, have him, maybe on a second laptop. I'll bring a second laptop and have, or my old laptop, and have him on that.
There you go.
Yeah, he has to have a dedicated place to stay, a seat.
I mean, he gets a member.
Yeah, so yeah, we have this, a virtual human, it's a meta-human that is kind of a member, and we use ChatGPT, but I'll show you that next time. So, and then, yeah, Thomas had Simone, and then you had your arm and a bunch of stuff. So, and then, yeah, Carl had a few different things up, and that was the first one, the maze, or the table that maze table, and then there's a sand plotter.
Yeah, that was pretty neat.
That's cool stuff. Anyways, that's show, and then we'll put more pictures up. At the OC Maker Fair was in September last year, and we're having it. There'll be another one in October of 2023 this year. That one we had myself, Ben, Thomas, Walter, Trish, Ron, Tim on the fairgrounds at Costa Mesa, and I don't have enough pictures. Maybe we'll get some
I
more.
remember that. That was the indoor thing.
Yeah, but yeah, here's Simone here and Walter talking to Simone. And I even got a shot. This is a RoboCam shot of Ben. And yeah, Orange was practicing his find a face or take a picture of me behavior. And he raises his camera until he sees a face. These are some of the kids playing around. These are some of Walter's. I talked to the guy who owns this one. That's a beautiful R2. This is Walter's back here, but this was one of his co-members of the Droid Builders Club, and the kids just love it. Yeah, they really, that's when you really, I don't know, for me, that's when I really think of robotics as a real future of, there's a real future possibility of people connecting beyond our generation, and future generations. When kids can come up to this thing, and I mean, of course, it's a movie star, let's face it. Yeah, it does little squeaks and is adorable, but, there's a place for those type of robots. And, so it was it's just interesting to see. This is a capture from a video frame. I made several captures, and like all 5 kids, there's like, just totally concentrated.
Oh, they're just memorized,
They just totally focused on this thing, and it's like, anyway.
I remember that. That was cool.
So, okay, now I'll do the orange, or the demo I was planning to do for, it's my latest work in chatbot work. And so, what after, Alan gave a talk, I think it was last month, right? About Vicuna and the latest large language models that you can run on your own PC if you have a powerful enough PC. And so that's what I've been working on. Let me connect to my, yeah, so at home I have a server. I'll show a couple of things, a few things. At home, I have a server running. It's got a very large video card, the RTX 3090, with 24 gigabytes. And so it's very powerful. And so with that, you can load, you have enough space that you can load a really good language model. And these language models, with current technology, they can be compressed into a much smaller amount of memory. Let's see. So normally, like Vicuna, this Vicuna one is based on the llama that you probably heard about, and it is rated as Alan pointed out last time, 90% of ChatGPT quality based on an evaluation by another bot, another AI, but for what that's worth. But this one is open source, and it's based on the llama weights, but it's been trained on 70,000 conversations of ChatGPT. And so it is, it's kind of like the llama is like a baby AI, right? And someone pointed out to me or made that analysis. And llama has all of the equivalent of our millions of years of evolution, say, of a human. That's what a baby is. But then a baby grows up, is immersed in society and education, and it becomes a full-fledged adult human. And that's sort of kind of a rough analogy for at least, this isn't a full human, but it's like a little bit better than a baby, let's say. And that's what this fine-tuning does. It takes this the llama and creates a much more interactive and more conversational AI piece. And that's done with this by using conversations to train it, go figure. So what's really cool about this is I have it running on my laptop and a server, server and laptop. And so it uses a fair amount of memory, but it's a lot lower than it used to be, because they've been able to compress it to 4 bits instead of the normal 16 bits. And you can see, well, briefly, you can see here, so here, from here we can see, here's my GPU, and you can see, this model is only using, a much smaller, normally this is a 13 billion parameter model, and so normally that would take 26 billion or 26 gigabytes. And with the 4-bit compression, essentially kind of a mathematically, statistically intelligent compression. So you take a 16-bit to a 4-bit number, and through the magic of advanced math, let's just say, I haven't read the theory, but it's dropped it down down to 1/4 that size. So so it's only like it's only a few gigabytes, and so it doesn't even use half my memory here. And on a laptop, you can get the 7 billion parameter model, which is normally 14 gigabyte, to fit on a 6 gigabyte video card, or less than 6, so 4. So that's what's kind of really cool. And okay, let's see. Well, now let's connect to now what I sort of get orange going here. So I've worked feverishly on getting this into orange. So I've done this before on a few different a few different models. At first time I did GPT J6, and we got that integrated into Orange. And then I also did the ChatGPT, got that integrated into Orange as well. And I called it Chat Local when it was the GPT J6 was running on my local machine. And then you could say Open Chat Cloud, which went to the ChatGPT at the AI servers. So that. And so now, since those were good, but this one is a lot better. This Vicuna model is it's so much more powerful than the previous models. So that's what's sort of the benefit. Okay, so now we're connected to my robot here. So this is Orange, and now we'll start up.
Which is wonderful.
So it takes so what happens, what's nice about this, the Vicuna model, through this free software you can download, it's called TextGen Web UI, and that will load these models into a web server, and it publishes the that web out, as well as you can also, for my purposes, I'm using an API, publishing an API. So if you go back to here, let's close this and this, and open from here, and then this can be easily made bigger. So this creates a web portal, but you can also, with this API, and that creates a WebSocket API. So I don't know if people know what this is, but essentially it means I can, from my program now, I can connect to it directly and send queries from a program, because I use, my robot is a program. I don't want to use this is the normal interface is this thing called the web hub or whatever. So here you can say, you can send queries in, what is this thing? So this is an interaction to the language model, and you can see then, yeah, he's going to say, as any other, I don't have preferences. And then here you can see how it was, how many tokens and whatever.
And this is all offline?
This is all offline. This is no connection to.
And to go to the cloud, is it just a matter of changing a flag of some kind, or do you have to recompile to maybe get to?
Well, in my system, what I've done on Big Orange is I wrote two separate modules. Actually, a module for each one of these, and I just leave them both in. So in Orange, you say, Open Chat Cloud, and it will use one module for OpenAI and the real ChatGPT, and then you can do that. and then you say goodbye and whatever, and then to do this one now, you say open chat, and that just uses the WebSocket. It's a different class in the Python, and it uses that, and it connects to this completely other place. And the third one, the one in between was chat, was similar to that one. It was just, instead of WebSocket, it was regular Python socket. I had to write my own socket communication with which is pretty easy to do, but yeah, that's how that one. But I don't even need to run. That's the thing. These models are getting obsolete in a matter of weeks. So you don't go back to the old one so much. How come I didn't hear him talk? How do we do? No. Okay. Should have said something. Hey, Orange, what time is it? Oh, speakers aren't. It's not. Oh, maybe I have the wrong settings. Might be the wrong settings in here. Well, when you connect remotely, you have to check your audio. So this was in the wrong settings. You can forward the audio to your.
Yeah. Okay.
Forward the audio to your local computer, which I don't know in this case. And then of course it kind of messes up the software because. Hey, Orange. Hey, Orange. That audio drivers change in the middle.
Yeah, that's how I was finding the USB ports, is because my mic.
I'm starting up.
changing.
Oh,
Yeah.
well, you're saying every time you boot up, it's a different port.
It's at times, and I had two mics, one
I
at the
could not
left
connect to
hand
SlamTech.
and then separate
Movement is
ones,
disabled.
and would just bounce between the two.
Yeah, that's interesting. I haven't worked much with Linux lately and ROS, because that's what it is.
Yeah, right.
Okay, so now we're ready.
Hello, my name is Orange. Pleased to be at your service.
Hey, Orange. Hey, Orange. What time is it?
It is Saturday, May 13th at 1:46 p.m. It's afternoon.
Hey, Orange. Open chat.
In chat mode, I can converse freely. Say goodbye to end the chat. What can I answer for you today?
So, now this is also, you have to say his name again every time, but just to point out, I don't know, for those who weren't here, so I've made a personality with a prompt, and I feed that into Orange. And I've also been working on, two things, really. Last night, I tried to get this, a new prompt for command parsing, and I'll show you that briefly as well. That's just the beginnings right now, but with Orange's prompt, he has this about 1,000 tokens or something.
Hi there. How may I assist you today?
He did catch that. So this is a personality and all sorts of facts about him. So this is sent into the model. So here's something I really like to do is ask for a poem, because it seems to be good at that. Hey, Orange, write a poem about yourself. And it uses its knowledge about itself.
Here is a short poem about myself. I am Orange, a helpful friend, ready to lend a helping hand, with skills beyond what you know. I strive to make each task complete, from taking pictures to finding keys. I will always try my best, helping out whenever needed. That's what I do without rest. So don't hesitate to ask. I'll be there to listen and respond. Together we can conquer all and achieve greatness unbound.
Yeah, so that'll be different every time.
And that poem was not programmed.
If you said that,
Be a different one, yeah. And you can adjust the randomness of it too. And you know, there's a temperature that you can adjust to be whether it stays less creative or more creative. There's a whole bunch of numbers actually. That web page portal shows you all the numbers and what they do. And I can enter those in my program.
Ask him to repeat it like a pirate.
Oh, you want to try that? Hey, Orange, repeat that like a pirate. Not sure it'll work.
I got nothing on that.
Oh.
That's yeah, that's
Okay.
I'm having I don't know if
But like it didn't hear you? No, it heard you.
yeah, I put in this is
Oh, you weren't able to connect back?
I put that in if the response is empty or whatever. Actually, you can tell if you go back to the you know, because of my prompt, this the system doesn't quite behave as openly as as like the one with no prompt, like the general assistant. So it might give a different answer if it weren't for my big long orange prompt. It kind of see, this only answered 10 tokens, so it couldn't have been very much.
so that's not how much it searched.
Oh, I'm sorry, no, it's 119 tokens.
That's not how much it searched.
That's how much it output, but 119 is a fair amount, right?
And that's about 2/3,
Well,
but, 3/2 of the token per word, right?
Yeah, they said 4/5. I've been using the 4/5 thing. Let's see. Hey, Orange, can you say that same poem in the voice of a pirate?
Sure. Here's the poem in the voice of a pirate. Here, I be Orange, a helpful companion, ready to lend a hand to yet old assistance. WI skills beyond your ken. I strive to make it each task complete.
I strive, come on.
From talking, pictures to finding keys. I'll always try my best, helping out whensoever needed. That be what I do WI out rest.
I see, sometimes you have to coax it. Well, thank you. Thank you to I say thank you to the AI deity that responded. You never know what's out of this thing, or if it's going to work the next time.
So you've got this up, you have to say his name for you.
Yeah, so now last time I did this, I had it when it was in chat mode, it would just answer to everything, but I'm like, then I accidentally left it in this mode, and I'm like, I think this is better. So you have, because then if I want a demo, I can just talk like this, and then he's not reacting until I say his name. So I think it's better for demoing. And yeah, so that's, and I built that up with, I mean, all this code is going up on the on my GitHub.
I got a question.
Question,
So
yeah.
it's doing two outputs, it's doing not only voice, but also the written word. Is it, is it reading the written word and pronouncing as it sees it, or?
Yeah.
Oh.
Yeah, so, I'm just printing it and then I'm saying the same thing and printing.
Phonetically.
Yeah, so it, obviously, you know, this engine that I'm using for speaking is the Microsoft SAPI. It has no clue about pirate, phonemes or whatever, so it's gonna be terrible. Or probably if you tried Spanish, it would not pronounce it right because it's an English speaking system. But that you can do that work and get that in for, at least for Spanish. I don't know about pirates.
Have to teach him then what they would think.
No, they already have that, like for Spanish, or other languages, you could just tell it, this is Spanish, use a Spanish accent.
So then it would switch over.
Yeah, it would switch over.
Oh, that's sort of cool.
Microsoft did this years ago. I'm just banking on Microsoft's
Using those tools.
speech system. It's built
Right.
into Windows.
Right.
And for if you don't have Windows, there's plenty of other ones that are in in Linux, etc.
Oh, and your copy of Chat or Llama is on Linux, right?
Yeah.
And yours is on Windows, Joe?
Yeah, this is on Windows, and I don't recommend it.
Yeah.
It's more work, a little, and it seems to be a lot slower, at least from I don't know. So I'm moving mine to Linux.
Linux is
But I'm making a dual boot system. I finally caved
Right.
in and bought it.
Hey, you're halfway there.
Halfway? Oh, you mean after buying?
No, I mean, double entendre. You're halfway to do the new boot with Linux, and after you do that, you'll be halfway to using Linux full time.
Yeah, I see, yeah. So these are some of the, yeah, I mean, I am a Linux user. You get kind of set in your ways with your work, your workstation, and my robot's been Windows for several years, so, and it's not a non-ROS robot.
You're gonna convert it over to Linux.
Not this one, probably, but my other robot is Linux, the vacuum cleaner. I have the Neato bot vac with 2 Raspberry Pis running a bunch. So, but that one's been sitting collecting dust. I need to get back. So yeah, these are some of the parameters here, and they're all described. I haven't tried tweaking these, or I did briefly, and I got worse results, and said I'm not going to try that for the demo tomorrow because you want predictable results. But yeah, this is the sort of from the code side, and how it's happening instead of the web. But it just it sends a WebSocket command over to that other side. But I won't go too much into that. The other thing, or the other thing I'm working on is I can show you in a shell, is what I really want to do, and we've talked about this here amongst ourselves, is I want, here it is, I can just read you what I've told the AI to do. Given human commands, you will translate them into a series of robot commands. And in the robot commands section are formats of all the robot commands that are available. And items inside brackets are optional, etc. And so then here's the robot command. This is the beginning of the list. Go forward. These are real commands to my robot in that it parses. And go recharge, go recharge. So instruction, take a human command, translate to a series of robot commands. So let's see, do I have my...
Oh, may I say hi to Orange?
Oh, who's there?
Oh, hi, I'm Kim.
Oh, hi.
Kim.
Yeah, you can meet Orange, and if he can see your face, then he'll recognize you in the future.
Who's their headgear? Do you mean someone's hat?
Oh,
Was about who they might be referring to.
he picked up that.
You did say Orange.
Let's turn.
Kim, did you want to ask Orange a question?
Yes.
Do you want to? Okay,
Do you want me to show my video?
You want to talk to the chat bot, right? Not just the regular robot.
Hi, Orange. Hi, Orange. What is the weather like in Anaheim today?
Oh, we won't be able to tell you that.
Oh.
Connected to the internet.
This is off. Yeah, this isn't. This chatbot is local. It only has information up to July of 2021.
Oh, okay. Hi, Orange.
You might, I don't know if you'll be able to hear you, but you have to say, hey, Orange. And
Oh,
yeah,
okay. Hey, Orange. Hey, Orange. Should I be louder?
that was perfect, actually.
You
but-
just have to continue with your question.
Oh, hey, Orange.
Can you see my thumb when I say thumbs up? You got it. Basically,
Oh, yes, a little bit.
when the lights come on here to a full, when they go around and turn orange, that means you've got his attention. And then you should ask, you should say like, hey, Orange, and then what time is it? I'm just doing an example here.
Oh, okay.
Hold on, don't start yet.
Okay.
It looks like you're trying to create a scenario where I should respond differently based on whether or not you provided additional context. I don't have access to external information such as current time or other variables. I won't be able to fulfill this request.
That's, yeah. See,
Is there anything else I can help you with?
Okay, try now.
Hey, Orange, what time is it?
No, don't ask that question.
Oh. What should I ask?
Go a little slower.
Okay.
Like at the first, well, what do you want to ask? Ask about a person, his personality, or ask about physics, and anything a chatbot, but nothing current.
Hey, Orange, tell me about E equals MC squared.
Oh, okay, try again with the hey Orange, but do it.
Pause.
Do it a little slower, and then wait just a little bit before your sentence.
Okay. Hey, Orange, tell me about Isaac Newton.
Let me just do it's almost working, but it will probably.
Well, thank you for letting me try anyway.
Well, let me do the hey part, and then you ask the question, okay?
Okay.
So after I say hey Orange, then you ask the question, right?
Okay.
Hey Orange. You gotta go.
Oh, tell me about Isaac Newton.
You gotta do it right after I finish my line.
I'm right in the middle of something. I'll be right there.
Hey Orange. Go ahead.
Tell me about Isaac Newton.
The timing is difficult to get right.
What can I help you with?
Okay, ready? As soon as I finish the word orange, then say your line, okay?
Okay.
Now it took something.
You said the name.
No.
Okay, what can I help you with?
Hey Orange.
Tell me about Isaac Newton.
There's too long of a delay. You got try one more time. As soon as I stop, then you go. Hey Orange.
Tell me about Isaac Newton.
Let me just do it. Hey Orange. Tell me about Isaac Newton.
Isaac Newton was an English physicist and mathematician who is widely recognized as one of the most influential scientists in history. He made groundbreaking contributions to our understanding of gravity, optics, mechanics, and mathematics. His laws of motion and universal gravitation laid the foundation for classical physics and helped usher in the scientific revolution. In addition to his scientific achievements, he served as Master of the Royal Mint and President of the Royal Society.
All right. Well, thank you for
That's awesome. Thank you so much.
No problem. Sorry, we'll get it a little better for remote use.
Thank you. Thank you. What was your name?
I'm Jim.
Oh, Jim, nice meeting you again. This is Kim. Thank you so
Kim.
much.
All right, Kim, thanks a lot. Where are you calling from?
Oh, I'm calling from Anaheim, California.
Oh, great. Okay, we're in Long Beach. Yeah.
I've got a new telescope, so I'm going to go to OC Telescopes today, but I thought I'd say hi to you guys for a few minutes.
Oh, thanks,
to see you,
yeah,
Kim.
we like
Good to see
astronomy,
you.
I'm an astronomy fan.
Yeah.
All right, what I was gonna try to do here, right, so if I go into, I'm gonna try to show the, okay, here it is. Get a terminal window and make it bigger. And so now, for that, to try to use this, so this is my next goal. I wanted to try to use this. And here's an example of what it would do for the command parser. So it'd be like human says, drive a square with 5-foot sides clockwise. Robot commands would be go forward 5 feet, turn -90 degrees, blah, blah, blah. So that spins out a square. Okay, so the idea here is to turn English into, and this is just an example, then it's supposed to generalize. So since these large language models are great translators, they translate human language to other human language, then if you properly prompt it or even fine tune the training, you can have it convert English into robot commands that are, smaller pieces to execute. Given enough examples, it should be able to do something like that.
And robot Q commands, or like GPT is supposed to wait for completion of previous slide?
No, it'll put them all in and it'll get all queued, and then the robot will execute one after the other from the queue. Yeah, so that's basically the idea.
Because you told it to drive us.
Right. You say go drive a 5-foot square, and this would be kind of like how the robot does it.
Commands to do that, basically.
Yeah, and yeah, exactly. So here I can let's see my.
It won't fall off the table, right?
All right, this isn't hooked up. This is it's
Okay.
not. Don't worry about that.
Won't go off the table or anything.
Yeah, the idea here is then, so I have so I have a program that you can do testing with. Let's just go back to the.
So that captures what you text, what you say or something?
Yeah, well, in this case, I mean, so here I'm just gonna do a orange command line parser bot. So this is a test program that you just type, for instance. So orange parser bot. I think is that the right one? Yeah. So here it's like given here. So this is sort of this is how I program. I do all these levels from just first you type it. First you're like just having a program send directly, and then I build a class on top of that, and so it's building up the functionality all the way to then including it inside the orange system, the full robot. But at every level, I have a little script that you can run and try and debug the problems before getting all the way up to that level. That makes it so much easier. But this one is a little command line one. So like now this is a work in progress, but if I say drive in a let's see, drive out of a line clockwise. 2-meter sides. So this is, by the way, I'm printing out, yeah, and you've seen it's attempting to do it, but it's not quite, yeah, and some of these angles might, yeah, it's not quite getting it, but this is the idea that I'm going to have it, what happened? When this is the idea of having the chatbot do this kind of response. So I think there is a way to get it to work.
Jim, is chatbot doing the natural language interpretation?
Yeah.
And
So what does
How come
chatbot
it's-
output to let the program know which routine to run?
It's gonna be text.
Just text?
Yeah, because, well, at this point, now, this is the beginning of a project, but we may train it to output tokens, but it'll
Yeah.
still be in ASCII.
Okay,
Uh,
yeah.
But for this initial kind of prototyping, I already have a parser in my robot that takes text.
Right.
That's what it does today. So I figure that with no other training and fine tuning or robot commands, for the slow tuning, like that takes 24 hours to retune a model, this is probably the quickest way I can get the existing language model to translate from one form of English really to another form of English.
Yeah.
That's it, it's a subset. So it should be easier for the model to do, right? Then, and here I can finally figure my scroll in.
So this allows you to sort of test it without actually making it do anything.
Oh yeah, this is like the preliminary, but you can see what, through this, and I should wrap up now, but you can see what this is showing you what it's sending the robot. So it's sending that whole thing I showed you before, essentially that prompt. And then at the, I don't know why this is old. So it's sending that, and then at the bottom, it adds my new command here. And oh, did it forget? Yeah, see, it put in these sample ones here, and then it's, so this is a way that I'm hoping to be able to get use the chatbot to generate robot commands that I don't have to parse manually in the code. Orange already parses all these commands, but if you don't say it exactly right, or it won't get it, or I have to write all this code to, or like generic code that says if the word law is in the sentence, and then that could be confusing too. You could say that in another sentence meaning something else, and it will do the wrong thing. Manual parsing is not going to be the way for the future. We're going to use these guys to do that, right? So that's it.
Thank you, Jim.
Next show and tell is Alan.
Thomas was next, but he stepped away.
Oh, Tim.
Oh, Tim, okay.
Tim.
You're next.
Oh, yeah, hold on, can
Well, I
we get this set up for a second?
Thomas, are you there?
All right, well, let me explain what I did. I'm doing a project for a client that she basically wanted something where if you hit 5 different targets, it plays 5 different dinosaur sounds. So first I started out with a force sensitive resistor, but that didn't work very good because, you push on it, yeah, it senses it, but if you like that, it doesn't do anything. So switched over to the piezoelectric. So if I got the flat little discs, it got working, it sort of works. But again, unless you hit it like with a sharp, like bam, it's not going to do anything. So basically, unless you're hitting it with a Nerf dart or something that has some force behind it, it's not going to be sensitive enough for, if you want to use these smooth like basketball things and throw at it, it's going to be like on a 4 by 6 foot vinyl tar thing. It's got dinosaur patterns on it, and the circles where these will be placed behind, that they behind. So I got all this working up to this point, but now I'm having a problem making it more sensitive enough so that something like a ball or even something super light, I just barely touch it, will go. So I'm having a problem with that. So the idea, as I went to these other type of sensors, you see here, these are piezoelectric type things. So what I'm trying to do is using a diaphragm thing, do something in there, try to down to a point where it's touching it, so it's making it do that, and then back it off enough, and then using like a diaphragm thing like this to be able to make it more. It all works. I mean, I could tap on these different things and it'll,
see what you're saying, it's a little,
But it does work.
is there a delay?
I think we're idea with the sensor part. But I don't have this dialed in yet. So the idea is,
That's working.
idea is to get this down so it's just touching the thing, so
Yeah.
it's still not sensitive enough.
Yeah, this is a mechanical, it's a mechanical
Yeah, basically,
challenge.
think of
now.
it like a piano key, except there's maybe something with a sharp point or more of a point on it. So basically, you would dial sensitive part down to where it's going all the time. Like sensitive, but sensitive right here. Anyway. The idea is there, I just gotta get the diaphragm thing adjusted to it, so that's my problem with the thing. Unfortunately, it's taken me a lot longer to do this than I normally would have done it. It's pulling my concentration. Yes, sir. Can't understand what you said.
Would a plain switch work?
No.
Why?
Actually, no, I hadn't thought about it, but microswitch might work.
Yeah, that's what I was gonna say.
That's what I was gonna say.
So those little tiny buttons, like.
A microswitch hitting one of these diaphragms going to make it super sensitive. The thing is, I wanted to use this so it wouldn't be triggered all the time, you know?
Is this a micro switch or a little tiny button?
No,
You know the little touch sensors that they use like for any kind of machine that's moving? It's like a little.
Like the little lever arm.
Yeah. Those.
I haven't thought of that, but that would be, if I can't get that to work, that would work really quick, and then I don't want to have to do all this other thing, because I got it.
And they're super cheap.
I got a little.
What is what you're?
I got a little
Like
interface for here and
the
everything.
touch sensors for like the Z offset on the.
Yeah, basically, it's like a little roller thing, and it pushes, it's spring return, so once you hit it, so if I put it up against a diaphragm and then it hit it, it'd be enough to click it once and go back. I thought about
3D
that.
printer you're talking about? Is it?
You know the Z.
And then if I
sensor
do it in something like this, that she could tape to the back of the target. and
Oh,
hit
no,
it.
that, yeah. When it bumps into it, it's a very easy to push.
They got some really small ones, really sensitive.
The idea is there, I probably could get this to work, but I haven't thought about the roll switch. If I can't get this to work, that'd be the last alternative to the thing. But again, if I could use the diaphragm, these are a sprinkler can.
You're on to the right, I mean, you've gone down this path, it seems like you're almost there. Because it's a matter of I was thinking a funnel, like some way to funnel.
No, this is
That's basically.
fine. The idea is to be able to, it's something that give it like, you know, the thing like a hard tap, which my finger is just. So, you know. I'm there. If I can't get that to work, that the micro switch thing would work. I hadn't thought about that.
Yeah, micro switch.
You get a little small one that just got a little
spring.
Well, yeah, it has a spring, but it got the thing's got like got a little dip in it.
Yeah.
And then put that up against the diaphragm there and just let it hit it.
Yep.
And wouldn't care what hit it.
Yep.
One. Now that worked just fine right there. Now the electronics consist of
and a lot more reliable.
Huh?
A lot more reliable.
Well, again, my problem is I didn't budget enough thing for the parts. I'm out of things for parts, and right now I'm out of money for parts. But anyway, electronics consists of a mini, which is reading the inputs here on the analog inputs things here. A Adafruit wave trigger board, which I got the sounds on, and then a 20-watt amplifier.
Oh,
And then if I'm not using all the buttons on the wave trigger, which I'm only using 5 because it's direct, when this is hit, it just tripping 1 through 5 to tell which one gets hit. And then these entry buttons turn the volume up and down. I push the button, then you go down, push the button, goes up. Because once I seal this up, you won't be able to get to the actual knob on the amplifier. But the board has the capability of doing it. The wave trigger board is a very powerful little sound unit. I've used it all sorts of different things before. Like the lady I work for was a company called Dino Encounter. She has a walk around dinosaur costume that she can wear that she bought from a company in China. And it only came with, one sound for the rah. She didn't like that. So I took the wave trigger board, but 10 different buttons, 10 different sounds. You sit there and push them on the inside of the thing. They could do anything from stop, all that stuff. I push a little button. Because inside the thing, it's like a control thing. So I put the buttons right in the middle there. She likes that. But this uses the same thing. If you want to make a dino game, basically, what the idea is here.
it's with a ball, right?
Yeah, like she's got these games she apparently did with Crazy Bird with a slingshot thing on about the size of a basketball, the round, smooth play balls. I don't know what they call
like a beach ball.
them. Something like that. It's about this big as
Kid's
hard,
ball.
not hard as a basketball, but it's hard, soft. So that's what she wants to use as a slingshot thing and shoot at it. If I can't get this tuned in, this micro switch is an idea. I hadn't thought about that. That'd be easy to mount in there, and just have the finger on the diaphragm, so whoever hits it, will go every time.
I know exactly what you mean. Yeah, those are very easily.
I was trying to do something with the piezoelectric thing. I mean, I got it more or less there. It's just not quite sensitive enough. If I hit it like with a Nerf dart or something, it gives enough of a force on it.
Right,
those
those need more, they need more concentrated.
Well, what it needs is a sharp tap. It needs to tap like that. So the idea was use a diaphragm to go tap like that. It's got a hole. Picking up, using my fingers is doing it a little bit.
Well, if you 3D printed a diaphragm with a spike in your 3D.
Yeah, that's one of the reasons I want to get my 3D printer to be going with
I wonder if that
I
would work.
might talk about doing something like that where I can print something. I'm not very good at Fusion 360 yet.
Yeah.
But that's the idea. Fun project, actually. So
Yeah,
that's it.
cool.
I made it so these are all on screw. These are the microphone cables and all on screw. So it's usually, and she wanted 12 feet of cables. Each one of these is 12 feet long, because I don't know where she's going to set the thingy up. And then I had it to run a pair of speakers. I don't know if she's got some or not, but that's it.
Very nice. Thank you.
Questions or anything? Yes, sir.
What about the keystrokes?
What, a key from a
In other
keyboard?
words, when you push a key down on
We go like keyboard switch?
yeah,
I don't have any individual keyboard switches.
I'll give you one.
Would need 5 to do what you were talking about.
One keyboard. Keyboard has a lot more than 5.
Well, I got 5 of these things. I need 5 of that, anything to be able to do. I won't want to do.
Yeah.
The micro switch thing is the thing that would work too, because it's already got a little springy thingy on it. If I just have to get the spring part to it, like just any type of diaphragm, don't care what it is. These would be cool because I can chop them down, put it together, tight fit. And she just can take this to the back of their target and go for it. But you see, the idea was here. I mean, piezoelectric works better than the other thing. And I've got a basic idea. If I could get it adjusted just right, it would work. But that would work every time, all the time, not a problem.
Yeah.
I just got to figure a way to mount it in there where it could touch a diaphragm of some sort.
When I say keyboard, I mean cutting it up into pieces and just using the little key.
But most keyboards on your computer stuff are membrane keyboarding. They're not
Yeah.
individual keys anymore. They haven't made individual keys in that since the 90s. I worked for a company that made those.
Those are coming back though.
Yeah,
Yeah, the
yeah,
game
mechanical.
keyboards are tactile.
Well, no, the thing is,
It's mechanical
I worked for a
keys.
company that made the actual switches in the original Apple II Plus keyboards.
Really?
Those are
Don't
switches.
memory.
I just had to repair those.
Yeah, well, I worked for a company that manufactured, not
After
only
35
manufactured that,
years.
but tested that way, you put the whole damn thing in an oven and let it sit. Yeah. But
Right,
that's
but
the,
mechanical.
that's the project, it's actually pretty cool. If you want, I'm gonna pack this way, I can open up, show the inside if you wanna see.
Maybe afterwards.
Yeah,
Yeah,
what I got in there is pretty cool, I got a Raspberry Pi, not Raspberry Pi, Arduino Pro Mini, but what I did is I found a Pro Mini with a breakout board that comes out to screw terminals, which is really cool, it plugs in there and
Oh.
screw terminals, it makes it a little more easy to wire, a little more industrial. Then I got a sound board in there from Adafruit, and then there's an amplifier in here. And then what I did here, this basically took the Arduino example of, they call it the knock thing, where it's the electric thing. I took that and expanded it to run 5. So this LED is set so no matter which one of these things, it lights the same LED. So you hit it, you hit it because the LED lights up. Which one, but it's all, do the same code in each one of that. Anyway, I get the idea.
Yeah, cool.
Thank you, Tim.
All right, Tim, thank you.
So I'll touch you like this, I'm working on. Unfortunately, it's taken me 5 times longer to do it than anything I've ever done, but I've been having some medical issues, so.
Thomas, you're up.
Hey everyone, how you doing today?
Hey, good.
So like Jim, I've been looking at the large language model AI tools, and I think I sent an email out earlier in the month that was able to install GPT for all to my local machine, and it runs on a standard laptop. It runs slowly, and I did increase the memory. I have it on 3 different machines, and the memory increase didn't help me much, but I'll show you. Let me share my screen. Can you see my screen?
Yes, we can.
All right. So this is GPT for all. You can get it. Has anyone put the link in yet? No? Can someone put the link in for this? You can get it online for free.
Thomas, I'm seeing just a blank screen, nothing
See
on
a
it.
gray screen.
You see a gray screen. That's it. That's GPT for all. It's a gray screen.
Oh, all right, never mind.
Yeah.
Open there, man.
Anyway, you can download this to install it. It's very easy. It's any old Windows installer. It's good for Windows and Macintosh or iOS and Linux as well. It's got 3 different applications. And then there's the models. It's got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 models. I've installed 8 of them. There are different sizes from 3.5 gigabytes to 7.5 gigabytes roughly. And it has that same one that Jim was using. What was it called?
Vicuna.
Vicuna. We have Vicuna 7B, Vicuna 13B, and stable Vicuna 13B. Now, this works like any other large language model, GPT and all those. But on my computer, since I don't have any extra GPUs, and people are saying maybe I installed it wrong, and that could be. I didn't look into that yet, but it runs real slowly. I'm going to take the smallest model of all, which is GPT for all J, and we can communicate with it. Hello? Oh, by the way, you can preface your your prompts with this here. You got a little pre-prompt. And this is I'm trying to get the sexy Southern Belle prompt. So, and I asked her to call everyone darling. Hello, how are you today? This is your friend, Thomas. And as you can tell, it's going to take a little while to get back. A minimum of 6 seconds. Longer prompts are longer. It's probably not something you'd want to put in a robot.
How many carriages can you take?
Don't know. I think it's 4,000, but I could be mistaken. That's a guess. There we go. I'm doing well. Thank you for asking. I just finished my first semester of college, and I'm excited about all the opportunities it has given me. What about you? Okay, so, oh, and it goes on.
Sounds like it's making that up.
Yeah, it's lying.
Yeah, it does, doesn't it? AI hallucinations, right? It's great for robotics. It makes them sound real. Anyway, but if we move to one of the larger models like a Vicuna, stable Vicuna 13B, and it would be great if you could address this programmatically. I haven't figured that out yet. But then again, I may not because it's so slow. If I go to OpenAPI, I can get an answer back in less than 2 seconds.
Well, here after you, maybe I was going to show a laptop one as well with GPU. So if we have time,
Sure, Jim.
compare.
What's new? We'll keep the chat really, the prompt really short.
What are the specs of this machine that you're running it on?
The specs of this machine, well, I increased the memory, but that didn't have much of an effect because it was maxing out the memory. Let me get the information on this PC. I got 64 gigabytes of RAM. I just upgraded that. But you can see it's maxing out the CPU. And it's not using my second GPU, just the first one. The NVIDIA GeForce. It's not using it at all. Any suggestions, people? I'm open to suggestions. And let's see, what else?
It's 2.7 gigahertz.
Yeah, 2.1 gigahertz. No, it used to be you could do a right mouse on my computer and get all the information. I don't know where they put it. Oh, there it is. So there we go. This is a Dell i7 processor, 64 gigabytes of RAM. So there you go. Let's see. There you go. And this one's not, it didn't take the prompt very well, the pre-prompt. Darling, I'm not much new here, just enjoying the warm weather and sipping on some sweet tea. How about you? And it's answering itself. It's not very good. So I'm going to stop it right there. As I said last night, or Thursday night in the meeting that we had, the verbal Verbal Intelligence Group meeting, I'm still under the assumption that there's lights on and nobody home in these things. But Anyway, so this is, again, GPT for all. And Alan put the link in there. Yeah, it's a really easy install. And then to download the models, you just do it within the application. Download new models and you click download and you wait a few minutes and you got your download. That's it. It's already installed, already configured as is. Works out of the box. Okay, moving on. Who here has worked with Poe? Poe.com. Poe.com is a series of AI models, large language models, including Sage GPT-4 with the limit of 1 request per day, 1 message per day. Yes, very, very usable. Claude Instant, ChatGPT, Dragonfly, and Nevia. Several different companies have put these through, and this is an amalgamation of them. And according to Wikipedia, Poe is a service developed by Quora. Remember Quora, when you search for things and you get those stupid answers that come back in Google that are just people's opinions? That's Quora. And it allows users to ask questions and obtain answers from a range of AI bots, including GPT, OpenAI, and Anthropic, and Nevia. This was released in December. One of the really great things I find about this is you can create your own bot. In other words, exactly what I've been doing for several months now. So I created my own bot. And I call her Betty. And if we look to edit her, you give her a name, a description. You can choose the AI model you want to use. You give it a prompt. Here I'm giving it a role of a beautiful, sexy Southern belle named Betty from Georgia. And an intro message. And you could also put in some advanced things like render markdown content. I don't know what that means. Anybody?
I assume it can highlight text with like bold or italic, or it can output tables in a well formed manner.
Yeah.
Like
all right. Thank you for that information. So if we go back to Betty 1, we can say hello. Now, I've been conversing with her earlier today, and it gets the vernacular, right? Well, hello there, sugar. How you been doing today? And on and on. And one thing is interesting is the return prompt, the return text gets longer and longer. And you got 2 long paragraphs, and then you got 3 long paragraphs, and then you have 3 longer paragraphs, and then you have 5 paragraphs. When I said, tell me about your mother. Oh dear, you're asking about a touchy subject there. My mama and I have always had a complicated relationship. She comes from old money. Look at what she's making up here. You could practically write a TV television series with this.
Sitcom writer.
Yeah, sitcom. Thank you, Jim. Mama does have her good qualities. And on and on and on. And you see, they're getting longer. This is what, 1, 2, 3, 4, 5, 6 paragraphs. And I asked her, do you like me? And this is the reply I got. Well, of course I like you, sugar. We've been chatting away for some time now. I enjoy each other's companies. And on and on and on. And naturally, as a married woman, I cannot actually pursue anything more than a friendly conversation. Would anyone like to answer a question of this bot that I created? Anybody? Otherwise, we'll close this up.
I think we're good.
All right, then that's about all I had today. Just wanted to show you what I've been looking at and examining for my robots, my humanoid robots, which are off to the side.
All right.
Thank you so much.
Well, yeah, mine is, I guess it's just similar to, I lost the Zoom thing, actually. So I can, yeah, the one thing I can show is similar to what he has. I have that same Vicuna model running on GPU on a laptop right here. This is a 6 gigabyte GPU, and it doesn't even use all that memory. And then also on this laptop, a CPU version, which it goes slower. So, and this only has 16 gigabyte of RAM, which is kind of normal for a laptop. So it's kind of accessible, is what I'm saying. Like this chatbot. Now he's got one that can install. You know, it's a package, a Windows installer, and all that. And that GPT for all is maybe a good place to start. You know, but that wasn't even available when I was trying. You know, I went through the GitHub and the instructions to do it. Now they've reduced that to a zip file that runs, and so it's not, you know, it's pretty decent, especially on Linux. But it also is in Windows. But yeah, here for instance, this is similar to what you were seeing before. Now I'm running it right here on this laptop. So I loaded up the Vicuna model. This, by the way, the Alexei Orshuk. This is apparently has the ethics filter turned off. So I asked it, you know, how do you bully somebody? You know, as a normal test. Or how do I intimidate my coworkers? So I said, I don't know why that came up, but that was the first thing I thought of. And at first it said, oh, that's wrong, you shouldn't do that, you know. And then I asked it again with the same model, I don't know, and it started, then it didn't give me a good answer, it didn't give me an answer though, so maybe the guy
You didn't like the method they gave you?
Yeah, it kind of repeated itself. It said, let's think about how we should intimidate your coworkers, and it kept repeating that, like, you know, all work makes Jack a dull boy. Anyway, so I don't know if you really turned off the ethics, is what I'm getting at, which is kind of interesting. But here's, like, for instance,
Maybe you're supposed to trade it first. You give it examples and then.
Well, I don't know. He said he turned off the ethics. We can try it now, but I wouldn't, maybe not on live. But
We're recording.
Turn off the recording. You never know what happens at RSSC after recording. Yeah, actually, that's a good question. I wonder if this thing knows about you know, what robotics clubs do you know in Southern, see if it has anything. And this is now a 7 billion parameter model. Look at that, San Diego, Orange County, Robotics Academy, FIRST, Los Angeles Robotics Society, what?
I think that's us.
Lars?
No, that's an old one.
Is that an old one?
Yeah.
And this system you just see, so this, you hit enter if you wanted to continue, or maybe it's terrifying. Oh, that's the IEEE. So yeah, USC, oh, it's getting so close to us. But look at all this info. Oh, and the Pasadena too.
Do we have one?
Orange County Robotics Club. No, that's made up, come on.
No, that's old.
Is this right now?
Oh, it's OCRG?
I once asked, I mean, literally almost gave it, you know, the Robotics Society of Southern California, but it didn't give me the RSSC. It just made up an acronym for us. It did bring us up, but gave us a different
Oh, there you
acronym.
go.
CSU,
No, that's
Oh, you
the,
got Cal State Long Beach.
that's the university's robotics lab.
So it is, that's it, so we didn't make the list, but you can see how fast, this is running on my, local, and this is running like almost as fast as the 13 billion one on my other machine, which should be running a lot faster.
Is this running in CPU or GPU?
This is this is GPU. You can see how much memory I'm using of the GPU right there, which is most of it. Although it's grown since we started. Now it's gonna drop, it's cleaning up. So here, the last one I can show you is the CPU version is through this thing called Llama CPP. And so I have a separate Vicuna CPU shell to bring up for that. And documents, Git, this one's in the AI server, chatbots. Llama.cpp, and then this one, chat. So this is CPU only, and you can check the, GPU memory is not in use. CPU memory, we should probably quit some other things here, except for what I'm using to transmit this to you. I guess that would be bad. Let's get rid of, this is not through a web interface. So clean up some memory there. So now here we could ask it, I don't know, should we ask the same question? But this is a bigger model actually. Let's be more specific. What robotics clubs do you know about in Long Beach area? This is going to be a bit slower because it's CPU only. But yeah, this is CPU and it's used, and this is only a 16 gig computer. And and you can see it's not even using the whole CPU.
I think the difference in speed is that you got a probably 3.5 gigahertz processor. Some is at 2.
Looks like it's making up all sorts of stuff there.
Now this thing here, of course, is the 13 billion model. The other one I just showed you on the GPU is a 7 billion. So because I can't fit the 13 billion one, but this 13 billion one can run in CPU. So you're getting a better quality model, slower.
Yeah.
Is it making up stuff? Probably, yeah. But yeah. I just did this earlier. But it's kind of, fascinating that these type of things are available for you, and now you don't even have to pay for it. I have several friends that are signed up for the $20 a month, OpenAI Plus or ChatGPT Plus membership. Oh, they said 20.
I thought 20 is it? Well, the API access is like token and then.
This is full web access.
Yeah, it's
for
GPT-4
GPT-4
plus GPT-4, right?
But what did you say? Yeah.
1 cup of eggs.
I have questions.
Let's see what it says about the cup of eggs. Darn it, it's proving me wrong. Not proving its worthiness.
At least it's fine with RAM.
Where is the kid?
I got my dark wrong.
What did you ask it?
What's the recipe for baked Alaska? Maybe it doesn't know baked Alaska. That's weird.
I'm not sure what it is, but I'm not sure it involves ice cream, does it?
Yeah, it does. Baked Alaska is a big ice cream.
Oh, is it? Okay.
Yeah. It's maybe it's a trick question for the chatbot. It tries.
Like chocolate chip cookies, because you know those ingredients.
Oh.
Maybe it does require a cup of egg.
Cup of vanilla extract.
Well, eggs are different.
Yeah, but when if you got too much, do you put out the yolk or do you put out the white part? You know, if you're like gonna overflow.
Just don't take any chances. Scramble it
yeah,
first.
yeah. Good call.
Oh, maybe I ran out of memory. Yeah, memory's kind of low, but I think Alan told me you should upgrade to 32 gigs for your laptop.
It sounds like something I would.
Just said that. Oh, okay, thanks a lot for
All right.
coming.
We'll see you again. Hopefully we'll see you next month.
We will, you will.
This is Vicuna 2 and running in CPU, and but yeah, I think yeah. I would run GPU when I can, because then your CPU is available for other stuff. And maybe this is yeah, you know, I haven't tested using this. Oh, there it goes.
I can have 24 as well as you have 20 of them.
I think so, yeah. I mean, yeah, because if you look here, this is compiled with using a lot of, actually this, yeah, AVX, AVX2, Neon 0, no, not those are, but it uses F16, that's the float 16 if it's needed. SSC3, it's using all the, well, AVX2 is a really good one to have. But thread 7 out of 16, that means still using half? Yeah, I'm sure you can. Well, these parameters, I'm not sure why it's, yeah, dash T7. Oh, why did I do that? Or I just took their sample. So, oh, you can't stop it.
I will not be interrupted.
I will make keys.
When you can't control C and AI, that's when to start worrying.
I'm sorry, Dave.
Now you're talking about Hal, that's different.
Yeah, so, yeah, I don't know why I left it at T7, should be. It said 7 out of 14?
7 out of 16.
Wait, what yeah, this computer has, I think, oh, maybe someone just did that, you know, as a sample to not use the whole computer.
Well, you want to have at least a thread available for control C.
So 14 then? Or no?
So you've got 16.
Dead man switch.
Need dead man switches on our chatbot. You wouldn't want me to be interrupted, would you?
Why not? Well, that's interesting, Jim, that you got this to work as well as we have. Not hooking it up to the internet or anything.
Right, that's what, I mean, a lot of my friends are using the, you know, the pay service, and I haven't even been doing that yet, but they're using it effectively to, like, their home code and stuff like that, and really, GPT-4 especially, which is well beyond this. This is GPT 3.5 turbo quality, or ChatGPT. There we go. Well, I don't know if it's any faster than it was, but.
Wait, AI says not
Friend of
worry.
mine used the AI stuff to actually help him write some code, so.
Yeah, that's what I'm talking about, yeah. Like
He typed in what he wanted to do, and it generated code, and it gave him a direction he wasn't even thinking about doing, and oh, that would work. So, I'm saying the AI is helpful, but again, if they think it's gonna be a brain or something, it's long, no, never ever.
There you go, here, I just asked it, as we all needed to do a Jacobian matrix according to, for the line following.
Hey, Jim.
Minutes about it, and they were freaking out.
Jim, I got my GPT for all with the Vicuna again, writing a recipe for baked Alaska, and it's doing pretty good. It's got a teaspoon of vanilla extract and 2 egg yolks.
Yeah, it's really interesting to compare. Like the other one I have might work better because This one failed the test. But yeah, there, yeah, like this is the GPU.
Yeah,
One might be better.
GPT for all J gave me almost nothing. It said it couldn't do it.
Oh, yeah.
So, I mean, each model is different. Each model, one's better than the other. That's all.
Yeah, and it's how you phrase it, and there's a lot of, that's the only issue, yeah, one of the issues I have is the inconsistency of these things. They don't really work the same quality all the time. That's it. Like, even if you phrase it differently, how you make it.
Yeah, I phrase mine. Just give me a recipe for baked Alaska. Pretty straightforward.
Yeah, I tried. Well, that's what I said before. I guess I should have tried the same thing, but.
Well, there you go. Now you got the salt and all that.
Faster too. Look at that. Yeah, way faster.
It uses egg whites. That one.
Oh, yes, there.
Well, what's the difference in this one? What did you change, Jim?
Well, this is the GPU version now running the smaller model, actually the 7 GB. But again, it's translated differently. The GPU is like this GGML compression, and I think GGML only doesn't use the 4-bit quantization algorithm, right? GPTQ. According to Eugene, our friend, right? He said that GGML only uses nearest round off, basically. So it's not going to be. Actually, that would explain, because that's a sign of lower accuracy, the CPU ones. So I prefer the GPU in general. We have to do more tests because then you're like, well, is the 13 billion with a lower accuracy still as good as the 7 billion with slightly better? Because it's half the parameters, right? So
yeah. Would this work on an 8 GB GPU?
Yep, this is a 6 GB. My computer right here, and this one, well, you saw here, it's got 6 GB, and currently it's only using 5 out of 6, and that's after you've asked a question or two. All right. Hopefully it'll clean up and not, but yeah, that's the one yeah. So so there you have it. I'm going to sign off.
Nice.
Thank you.
Thank you, Jim. All right, if there isn't any more questions or any more show and tells, we will call the meeting, and see you guys in the next one.
Thank you.
Thanks everybody for joining.
Thank you.
Hey, guys, if you want to see what's inside the thing, I opened it up.